Yet, as we discover more, new questions arise, questions that are even more complex and profound. What is the universe? How did it come into existence? What role does humanity play in it? These questions remain relevant today, despite all the achievements of science and technology. Modern cosmology is a science that not only unveils the mysteries of the universe's origin and evolution, but also helps us understand the nature of time and space, the forces that govern galaxies, stars, and planets. At the core of these studies lie the fundamental laws of physics, which explain how the initial singularity known as the Big Bang gave birth to the universe approximately 13.8 billion years ago. This moment, filled with energy and matter, marked the beginning of everything we know, the beginning of time, space, and all that fills the cosmos. From chaos emerged structure, stars, and galaxies, within which planets eventually formed, one of which became our home. Despite our insignificance on the cosmic scale, humanity has always strived to understand its place in this vast expanse. We are but specks in the infinity, yet within our minds and hearts burns a desire for knowledge. How did life arise on Earth? Are we alone in the universe? What future awaits humanity? These questions present not only scientific but also philosophical challenges, prompting us to contemplate the meaning of existence and humanity's role in the cosmic scale. Throughout history, we have sought answers to these questions, yet each answer we find leads to new mysteries. We see stars that extinguished millions of years ago, observe galaxies that we will never approach, and realize that our lives are but a fleeting moment in the infinite chain of events occurring in the universe. In this text, we will embark on a fascinating journey through the vastness of space, from the origins of the universe to its possible end. We will explore how our understanding of the cosmos has evolved, what discoveries scientists have made, and what questions remain unanswered. We will also seek to understand humanity's place in this infinite universe and how our understanding of space can influence our future. In this journey, we will consider not only scientific aspects, but also the philosophical and cultural implication of our discoveries, striving to comprehend what it means to be human in such a vast and mysterious world. Space is not just the void between stars, it is an ocean of time and matter, where every atom of our bodies was born in the hearts of distant stars. Understanding this connection to the cosmos opens up new horizons, driving us to further exploration, new discoveries, and perhaps a re-evaluation of our place in this grand cosmic order. We embark on this journey not only to seek answers, but also to experience the beauty and grandeur of the universe, to realize our connection to it, and to find inspiration in its boundlessness. The universe we inhabit is a grand and awe-inspiring object of study. It is home to billions of galaxies, each containing billions of stars and an incalculable number of planets, comets, and asteroids. Everything we see and everything that exists is governed by the same physical laws that describe the behavior of matter and energy. But how did this vast and complex structure come into being? The question of the universe's origin remains one of the most profound and intriguing mysteries of modern science. According to the prevailing theory, our universe emerged from a state of extremely high density and temperature around 13.8 billion years ago in an event we refer to as the Big Bang. The Big Bang is not merely an explosion in the conventional sense. Rather, it represents the moment when space and time, as we know them, began to exist. At this moment, all matter and energy were concentrated in a single point, known as a singularity. This state was so extreme that the physical laws we use to describe everyday reality could not be applied. Gravity, electromagnetic forces, strong and weak interactions, all these fundamental forces existed in a form that we have yet to fully comprehend. It was a moment of pure potentiality, a moment when everything that exists today was in a nascent state, waiting to be born. From this singularity, the universe began to expand, and this expansion continues to this day. This process can be imagined as the incredibly rapid inflation of space, where every point moves away from every other point, similar to how points on the surface of an inflating balloon move away from each other. It is crucial to note that this expansion is not happening within pre-existing space. Rather, space itself is expanding. This distinction highlights the uniqueness of the Big Bang as an event that initiated not only matter and energy, but also the very concepts of space and time. Initially, immediately after the Big Bang, the universe was incredibly hot and dense. Temperatures reached trillions of degrees, and matter existed in a form with no modern analog. In these conditions, elementary particles such as quarks and gluons were in a state of free movement, forming a kind of soup. These particles interacted with each other, constantly being created and annihilated until the temperature gradually dropped to the point where quarks could combine to form protons and neutrons, the building blocks of atomic nuclei. Something remarkable was occurring. From the primordial chaos and disorder, ordered, structured matter began to emerge. Within the first few minutes after the Big Bang, processes of nucleosynthesis began, leading to the formation of the first nuclei of light elements, such as hydrogen and helium. These processes occurred under conditions where the density and temperature were so high that individual nuclei could collide and fuse, forming heavier elements. This initial nucleosynthesis concluded relatively quickly, leaving behind a universe primarily filled with hydrogen and helium, along with trace amounts of lithium and other light elements. These light elements became the foundation for the subsequent formation of stars, galaxies, and all the structures we observe today. It is important to note that this process was not random. It followed specific physical laws that operated with incredible precision and predictability, creating the conditions necessary for the formation of complex structures from the primordial material. Thus, the Big Bang not only marked the beginning of everything that exists, but also laid the groundwork for the development of the universe as we know it. One of the key pieces of evidence for the Big Bang theory is the existence of the cosmic microwave background radiation, CMBR. This radiation, a sort of echo of the Big Bang, represents the relic light left over after the universe cooled and became transparent to photons. In the first moments after the Big Bang, the universe was opaque to radiation due to its high density and temperature. Photons, particles of light, constantly collided with electrons and other particles unable to travel freely. However, about 380,000 years after the Big Bang, the temperature dropped to the point where protons and electrons could combine to form neutral hydrogen atoms. This process, known as recombination, made the universe transparent to light. From this moment on, photons were able to move freely, and this radiation, which we observe today as the CMBR, became a sort of photographic imprint of the early universe. The CMBR reveals that the universe was nearly homogeneous in its early stages, with very slight density fluctuations. These fluctuations are believed to have been caused by quantum processes occurring during the moment of inflation and eventually became the seeds for the formation of galaxies and star systems that we observe today. These small density variations became the regions where gravity began to concentrate matter, leading to the formation of the first stars and galaxies. The discovery of the CMBR in 1965 by Arnaud Penzias and Robert Wilson was a crucial confirmation of the Big Bang model and provided scientists with a deeper understanding of the early stages of the universe's development. Detailed study of the CMBR using modern satellites such as COBE, WMAP, and Planck has allowed us to create an accurate map of the early universe, measuring its age, composition, and density. These data confirm that the universe is indeed expanding, and that its history began with the hot, dense state we call the Big Bang. While the Big Bang theory gives us a general picture of the universe's origin, it does not explain all the details. For example, it cannot account for why the universe appears homogeneous and isotropic, that is the same in every direction, on large scales. Questions related to the flatness, homogeneity, and lack of magnetic monopoles in the universe remained unresolved within the framework of the classical Big Bang theory. To address these issues, the inflationary theory was proposed, which suggests that in the first fractions of a second after the Big Bang, the universe underwent a period of exponential expansion known as inflation. Inflation was a brief but extremely powerful period of expansion during which the size of the universe increased by trillions of times in a minuscule amount of time. This process smoothed out any initial irregularities and made the universe nearly uniform in all directions. Without inflation, different regions of the universe, located far apart from each other, would not have been able to agree on their properties, as the speed of light limits the exchange of information between them. However, inflation explains how these regions could come to such an agreement despite their distance. Inflation resolved several problems of the standard Big Bang model. First, it explained the homogeneity and isotropy of the universe, as during inflation, any initial inhomogeneous distribution of matter and energy was smoothed out. Second, the inflationary theory provided an explanation for the origin of the density fluctuations that led to the formation of structures such as galaxies and galaxy clusters. These fluctuations arose from quantum fluctuations, which were stretched to macroscopic sizes during inflation. Additionally, the inflationary theory predicts the existence of primordial gravitational waves, ripples in space-time that could have been generated by this rapid expansion. The search for traces of these waves in the CMBR is one of the tasks of modern cosmology and could be key to confirming or refuting the inflationary model. Inflation also opens the door to deeper questions about the nature of the very beginning of time and space. What caused inflation? What conditions led to its initiation and termination? How are these processes related to quantum gravity and possible theories of everything? These questions remain subjects of active research, and their resolution could lead to a new understanding of not only the universe's origin, but also the fundamental laws of nature. Thus, the Big Bang and the subsequent inflation laid the foundation for the formation of our universe as we know it. This beginning, filled with both revealed mysteries and new questions, is only the first step on a long journey that scientists continue to explore, striving to understand both the universe itself and our place within it. After the period of inflation ended, the universe continued to expand, but at a much slower pace. This stage can be seen as the beginning of a long process during which the universe began to take on its modern characteristics. Space was still filled with hot and dense gas, composed of elementary particles, which were just beginning to form into more complex structures. It was during this phase that processes began, leading to the emergence of atoms, stars, galaxies, and other cosmic objects that we observe today. Approximately 380,000 years after the Big Bang, the temperature of the universe decreased to the point where protons and electrons could combine to form neutral hydrogen atoms. This process, known as recombination, marked a significant milestone in the history of the universe. Before this moment, free electrons hindered the propagation of light, and the universe was opaque. However, after recombination, photons could travel freely, leading to the emergence of the cosmic microwave background radiation, CMBR, which we observe today. Recombination also led to the formation of the first helium atoms and traces of lithium. These light elements formed the foundation for the subsequent formation of stars and galaxies. It is important to note that at this stage, the universe was primarily a dark place, not in the sense of the absence of light, but in the sense of the absence of visible structures. It is believed that this was the beginning of the so-called Dark Age of the universe, when light had not yet been emitted by the first stars, and space was filled only with rarefied gas and dark matter. Even during this time, important processes were occurring. Dark matter, which does not interact with ordinary matter electromagnetically, but exerts gravitational influence, began to concentrate in dense regions, forming a sort of skeleton for future galaxies. This process of gravitational contraction of matter into dense regions became the foundation for the formation of the first stars and galaxies. Several 100 million years passed after the Big Bang before the first stars began to form. These stars, known as population 3 stars, became the first sources of light in the young universe. They consisted almost entirely of hydrogen and helium, since heavier elements did not yet exist. These stars were much more massive and brighter than modern stars, with masses exceeding hundreds of solar masses, and their lives were short and turbulent. Population 3 stars played a key role in the processes of nucleosynthesis, enriching the interstellar space with heavier elements such as carbon, oxygen, and iron. These elements, known as metals in astrophysics, became the basis for the subsequent formation of planets and more complex chemical compounds necessary for the emergence of life. These early stars also contributed to the ionization of hydrogen in the surrounding space, a process known as the epoch of reionization. Reionization was the process in which the ultraviolet radiation from the first stars and galaxies ionized neutral hydrogen, splitting it into protons and electrons. This process ended the Dark Age and ushered in a new era where visible structures, stars, galaxies, and galaxy clusters began to form. Reionization was an important stage in the evolution of the universe, as it laid the foundation for the formation of the first galaxies and large-scale structures we observe today. As population 3 stars evolved and ended their lives in powerful supernova explosions, they enriched the surrounding space with heavy elements, creating the conditions for the formation of subsequent generations of stars, population 2 and population 1 stars, which make up most of the stars observed today. These subsequent generations of stars became the building blocks for the formation of galaxies, such as our galaxy, the Milky Way. As the universe continued to expand, gravity played a key role in the formation of large-scale structures. Gravitational forces led to the contraction of matter into dense regions, where galaxies, galaxy clusters, and superclusters began to form. In these regions, new stars formed, and the interstellar space filled with gas and dust, creating the conditions for the birth of planetary systems. The formation of galaxies and large-scale structures in the cosmos is a complex and multi-stage process involving gravitational interactions, collisions, and mergers of galaxies and the dynamics of dark matter. Dark matter, which makes up most of the mass in the universe, created gravitational wells into which ordinary matter was drawn, forming galaxies and their clusters. Modern astronomy observes various types of galaxies: spiral, elliptical, and irregular. These forms reflect the complex processes of mergers, interactions, and the evolution of galaxies. Spiral galaxies like our Milky Way have beautiful spiral arms where stars actively form from clouds of gas and dust. Elliptical galaxies, on the other hand, are older and more tranquil systems where star formation has nearly ceased. Irregular galaxies have chaotic shapes and are often the result of gravitational interactions or mergers with other galaxies. Galaxy mergers are an important process that significantly impacts their evolution. When two galaxies collide, their stars and gas clouds begin to interact, which can lead to bursts of star formation, the formation of new star clusters, and even changes in the galaxy's shape. In some cases, a merger can lead to the formation of an elliptical galaxy from two spirals. For example, our galaxy, the Milky Way, likely formed from the merger of several smaller galaxies and continues to evolve through the accretion of matter and star systems. In the future, our galaxy will collide with the neighboring Andromeda galaxy, and this collision will lead to the formation of a new, larger galaxy that may become elliptical or lenticular. The development of galaxies and large-scale structures is one of the key processes in the evolution of the universe, and it continues to be studied by astronomers worldwide. Observations made using powerful telescopes like Hubble and James Webb help scientists not only peer into the distant past of the universe, but also understand how it will evolve in the future. These studies give us insight into how the universe gradually evolved from the hot and dense state characteristic of the Big Bang to the grand and complex structure we observe today. The evolution of the universe is a process that continues, and we are part of it. Understanding this process helps us better comprehend our place in this vast and ever-changing cosmic order. The question of whether life is unique to Earth or widespread throughout the universe is one of the most exciting in modern science. Life as we know it requires certain conditions to exist, such as the presence of liquid water, specific temperature ranges, and a particular chemical composition. However, on the scale of the universe, these conditions might be found in the most unexpected places. There are billions of stars, each potentially hosting its planetary system, and while conditions on most of these planets are likely unsuitable for life, even a small percentage of habitable worlds opens vast possibilities for the existence of extraterrestrial life. Earth is the only known place where life exists. The emergence of life on our planet remains one of the greatest mysteries of science. How did life arise from non-living matter? This question has occupied the minds of scientists for centuries. It is believed that life on Earth originated approximately 3.5 to 4 billion years ago, during a period known as the Hadean Era. At that time, Earth was a hot, volcanically active world with an atmosphere rich in carbon dioxide, methane, and ammonia. Despite these extreme conditions, chemical processes occurring in the oceans and atmosphere created the conditions for the emergence of the first organic molecules. The process of life's origin involves several key stages. The first step was chemical evolution, during which simple molecules such as water, methane, ammonia, and carbon dioxide began to form more complex organic compounds, amino acids, nucleotides, and lipids. These molecules could have formed through various natural processes, such as electrical discharges, ultraviolet radiation, or thermal energy, for example, in deep-sea hydrothermal vents. The next critical stage was the aggregation of these organic molecules into more complex structures, proto-organisms capable of self-replication and metabolism. This stage is the most mysterious, as the exact mechanisms that led to the emergence of the first self-replicating systems are still unknown. However, It is believed that RNA molecules, which are capable of both storing genetic information and catalyzing chemical reactions, may have played a crucial role in this process. Over time, these simplest organisms became increasingly complex, passing through stages of evolution that led to the emergence of prokaryotes, then eukaryotes, and eventually multicellular organisms. These changes occurred over billions of years, resulting in the vast diversity of life forms we see today, from microorganisms to complex organisms such as plants, animals, and humans. The origin of life on Earth is also closely tied to the evolution of the environment. For example, the emergence of photosynthesis, which produces oxygen, altered Earth's atmosphere, creating conditions for the development of aerobic organisms and ultimately more complex forms of life. This process also led to the formation of the ozone layer, which protected the planet's surface from harmful ultraviolet radiation. The question of life beyond Earth has been a subject of discussion and speculation for centuries. With the advancement of science, this question has become the focus of serious research. Today, scientists actively study various objects in the solar system and exoplanets located in habitable zones where conditions might be suitable for life. Mars, for instance, has long been considered one of the most likely candidates for harboring life. Recent missions, such as the Curiosity and Perseverance rovers, are exploring the planet's surface for signs of ancient life, such as organic molecules and geological structures indicating the presence of water in the past. Although the surface of Mars today is cold and dry, there is substantial evidence that liquid water may have existed on the planet in the past, a key condition for life. Geological data suggests the existence of rivers, lakes, and possibly entire oceans in ancient times, which could have created favorable conditions for microbial life. Moreover, the moons of the giant planets, such as Europa and Enceladus, also attract the attention of scientists. Beneath their icy crusts, there may be oceans of liquid water, potentially capable of supporting life. The water geysers observed on Enceladus, ejecting plumes into space, indicate the presence of a subsurface ocean that might be heated by hydrothermal vents on the ocean floor. These conditions could be analogous to those that existed on early Earth, representing potential niches for life. However, the search for life is not limited to the solar system. Thanks to advances in astronomy, scientists have discovered thousands of exoplanets, planets orbiting other stars. Some of these exoplanets are located in the so-called habitable zones, where conditions might be suitable for the presence of liquid water. An example of such a planet is Proxima Centauri b, which orbits the star Proxima Centauri, the closest star to us beyond the solar system. The search for life on these exoplanets involves not only observing their atmospheric characteristics, but also searching for biosignatures, chemical traces that could indicate the presence of life. Molecules such as oxygen, methane, and ozone might suggest biological activity if found in significant quantities in the atmospheres of these planets. Current and future telescopes, such as the James Webb Space Telescope, will play a crucial role in searching for these biosignatures and understanding the potential for life beyond Earth. One of the most intriguing questions regarding extraterrestrial life is the so-called Fermi paradox, named after the physicist Enrico Fermi. The question Fermi posed is simple: where is everybody? If life is widespread in the universe, why do we not see any signs of other civilizations? This question has led to numerous theories and speculations about the nature and fate of intelligent life in the universe. There are various answers to this question. One hypothesis suggests that intelligent life in the universe may be extremely rare. Perhaps the conditions necessary for the emergence of intelligent life are so specific that they only occur on a few planets. Moreover, Even if intelligent life does emerge, it may not last long due to various threats such as global catastrophes, self-destruction, or technological barriers. Another hypothesis proposes that advanced civilizations might be avoiding contact with us or using technologies that we have not yet detected. This idea is known as the zoo hypothesis or cosmic quarantine, suggesting that more advanced civilizations might deliberately avoid contact with us, observing us from afar, or even hiding their presence. Perhaps they consider us not yet developed enough for contact or fear interfering with our natural course of evolution. Another theory suggests that we are simply not looking for the right signals or not searching actively enough. Most of our attempts to detect extraterrestrial civilizations are based on radio-astronomical observations, but advanced civilizations might use entirely different means of communication or technologies that we have not yet discovered. The Fermi paradox remains a significant challenge for scientists and philosophers pondering our place in the universe. It raises questions not only about how unique we and our planet are, but also about what it means to be intelligent beings in such a vast and unexplored cosmos. The answers to these questions could change our perception of the universe and our place in it, as well as determine our future actions in the search for extraterrestrial life. Thus, life in the universe remains one of the most mysterious and fascinating topics in modern science. The research continues, and every new step brings us closer to understanding whether we are alone in the universe or part of a larger cosmic community. When we look up at the stars, we confront the immeasurable expanses of the cosmos, which can make us feel insignificant and alone. Space stretches billions of light years in all directions, and within this infinite expanse, Earth seems like nothing more than a tiny grain of sand. Yet, on the other hand, the realization of our place in the universe allows us to understand that we are part of something much greater than ourselves. We are the children of the stars, created from the same material as galaxies, stars, and planets. This awareness brings not only humility, but also inspiration to our existence. One of the most iconic images of our planet is the photograph taken by the Voyager 1 spacecraft from about 6 billion kilometers away from Earth. In this photograph, Earth appears as a tiny, pale blue dot against the vastness of space. This small dot, barely visible in the image, contains everything we know: our history, culture, science, art, and all the lives that have ever existed. This image has become a symbol of our planet and our existence. Reflecting on this photograph, Carl Sagan said, "Everyone you love, everyone you know, everyone you ever heard of, lived out their lives on this tiny mote of dust, suspended in a sunbeam." These words remind us of the fragility and uniqueness of life on Earth. In the grand scale of the universe, our planet is just one among billions of worlds, yet it is our only home. This realization makes us ponder our responsibility toward this planet and toward each other. The pale blue dot effect prompts deep reflections on our role in the universe. It emphasizes how small and fragile our world is, while also underscoring the importance of its preservation. This perspective urges us to care for Earth, to understand that our well-being is inextricably linked to the planet's health. We are the sole guardians of this unique dot in the universe, and its future depends on us. This photograph also symbolizes our unity as a species. Regardless of nationalities, religions, or cultures, we all share this tiny planet. In the vastness of space, our differences seem trivial. We are all on the same cosmic vessel, traveling through the universe, and our destinies are interconnected. This understanding can serve as the foundation for creating a world where respect, cooperation, and care for our common home become the primary values. When considering our place in the universe, we inevitably think about the future of humanity. Will humans ever leave Earth and settle on other planets? This idea, which seemed like science fiction not long ago, is becoming increasingly realistic thanks to advancements in space technology. We are already planning missions to Mars, exploring the potential for resource extraction from asteroids and building international space stations. The colonization of Mars, the construction of space stations, and the exploration of asteroids could all become part of our future. These projects open new horizons and possibilities for expanding humanity's presence beyond Earth. However, we must remember that wherever we go, we carry the responsibility to preserve our cultural and natural heritage. Humanity's future in space depends not only on our technical capabilities, but also on our ethical and philosophical approach to exploring new worlds. We must remember that every step into space should be thoughtful and responsible. Our actions could affect the future of entire planets, and we must act with respect for nature and life if it is discovered on other worlds. The colonization of other planets should not be seen as an opportunity for exploitation or destruction, but as a chance for a new beginning, founded on respect and harmony. Moreover, humanity's space future raises new philosophical and moral questions. How will we interact with possible extraterrestrial life? How will we organize society on other planets? What will laws and rights look like in a spacefaring society? All these questions require deep consideration before we take our first steps beyond our planet. The cosmic perspective also compels us to realize that Earth is our common home, and until we find another habitable place, we must do everything possible to preserve it. Space exploration should not become an excuse for neglecting our duties toward our planet. On the contrary, it should reinforce our understanding of the importance of protecting and preserving Earth as a unique and precious world. Understanding the cosmic perspective is not just a scientific task, but a philosophical reflection on our existence. We live on a small planet in one of billions of star systems in one of billions of galaxies. But it is precisely this realization that helps us see how important every moment of our life is, how unique and valuable our existence is. When we gaze at the stars and grasp the vastness of the cosmos, we are filled with awe at the scale of the universe. This feeling can be both frightening and inspiring. On the one hand, we understand how small and insignificant we are in the grand scheme of the universe. But on the other hand, this awareness makes our lives all the more precious. Every moment, every choice, every action gains meaning in the context of the vast cosmos in which we exist. The cosmos teaches us humility while simultaneously inspiring us to achieve great things. It reminds us that in the face of infinity, every person and every life matters. It also makes us ponder questions that go beyond the ordinary, the nature of time and space, the beginning and end of all that exists, the meaning of existence. These questions drive us to seek answers and strive for knowledge, which in turn defines our place in the vast universe. The cosmic perspective allows us to see the world in its true scale. It shows us that our lives are but brief moments in the history of the universe, yet these moments hold immense significance. This understanding motivates us to explore and learn, to strive for harmony with nature and the universe. Embracing the cosmic perspective can lead us to a new level of spiritual and moral development, to an understanding that we are part of something great and infinite. Ultimately, realizing our place in the universe helps us find meaning in our lives. We are not mere accidental creatures on a tiny planet in a vast galaxy. We are the result of billions of years of evolution, bearers of consciousness capable of understanding and contemplating the universe. This understanding can inspire us to achieve great things, to create a world where knowledge, respect, and the pursuit of peace and harmony become the core values. Thus, the cosmic perspective is not just a look at the stars, but a deep understanding of our role in this vast cosmic order. It teaches us to see the world more broadly, to think globally, and to act responsibly. This understanding can transform not only our attitude toward space, but also our attitude toward each other and our planet, making us more conscious and wise guardians of life on Earth. Our understanding of the universe is far from complete. Despite all the scientific achievements, there remain questions that challenge our knowledge and imagination. Some of the most enigmatic objects and phenomena studied today are black holes, dark matter, and dark energy. These cosmic phenomena not only astonish and captivate our imagination, but also play a crucial role in the evolution of the universe. They push us to reconsider the fundamental laws of physics and make us wonder what else lies hidden in the vast expanses of space. Black holes are among the strangest and most mysterious objects in the universe. They are regions of space-time with such strong gravity that neither light nor matter can escape their grasp. The term black hole was first coined by American physicist John Wheeler in 1967. Although the concept of these objects dates back to the work of Carl Schwarzschild and Albert Einstein in the early 20th century. Black holes form when a massive star exhausts its nuclear fuel and its core collapses under its own gravity. The result is an object with extremely high density and gravity, known as a singularity, surrounded by an event horizon, the boundary beyond which nothing can escape. This zone represents a kind of point of no return, and anything that crosses the event horizon is forever lost to our perception. There are various types of black holes, depending on their mass. The most well-known include asterisk, stellar mass, black holes asterisk. These form from the collapse of massive stars and have masses ranging from a few to dozens of solar masses. They can exist alone or in binary systems, where their presence is often detected through interactions with other objects, such as nearby stars or accretion disks. Asterisk, supermassive black holes. Asterisk. These giants reside in the centers of galaxies and have masses ranging from millions to billions of solar masses. They are believed to play a key role in the evolution of galaxies, significantly influencing their shape, dynamics, and star formation processes. An example of such a supermassive black hole is Sagittarius Asterisk at the center of our galaxy, the Milky Way. Asterisk. Intermediate mass. Black holes asterisk. These objects, with masses ranging from hundreds to thousands of solar masses, are the subject of active research. Discovering and studying them could provide insights into how supermassive black holes form and evolve over time. One of the most exciting topics in modern astrophysics is the study of the event horizon and what happens inside a black hole. Einstein's theory of relativity predicts that time slows down and space warps around a black hole, leading to paradoxes that require new theories for explanation. The most extreme effects occur near the event horizon, where gravitational forces are so strong that they break down the usual laws of physics. The study of black holes is also closely tied to research on quantum gravity and the nature of space-time. One of the most famous questions in this area is the information paradox associated with black holes. This paradox arises from the fact that black holes, according to Hawking's theory, can evaporate through a process known as Hawking radiation. However, this process challenges the conservation of information in quantum mechanics, representing one of the unresolved problems in modern physics. One of the most intriguing mysteries in cosmology is the nature of dark matter. This invisible substance neither emits nor absorbs light, but its presence can be inferred from its gravitational effects on visible matter, such as stars and galaxies. Dark matter plays a crucial role in forming structures in the universe, such as galaxies and galaxy clusters, and constitutes a significant portion of the universe's total mass. The idea of dark matter was first proposed in 1933 by Swiss astronomer Fritz Zwicky, who noticed that galaxies in the Coma cluster were moving faster than could be explained by the visible matter alone. This effect, known as the missing mass problem, was the first evidence of dark matter's existence. Later, in the 1970s, astronomer Vera Rubin discovered that stars in the outer regions of galaxies were rotating faster than predicted, further indicating the presence of unseen mass. Dark matter makes up about 27% of the universe's mass-energy content, far surpassing the proportion of ordinary baryonic matter, which comprises stars, planets, and us. However, despite its importance, the nature of dark matter remains unknown. Various hypotheses suggest what it might be. One of the most popular hypotheses proposes that dark matter consists of particles that interact weakly with ordinary matter. These particles, if they exist, might be detected through collisions with atoms in specialized detectors located deep underground. Another candidate for dark matter is hypothetical particles, proposed as a solution to the strong interaction problem in quantum chromodynamics. These particles could be detected through their interaction with electromagnetic fields. This hypothesis suggests that dark matter might consist of objects like black holes, neutron stars, or brown dwarfs, which do not emit light but exert gravitational influence. The search for dark matter continues through various experiments, such as particle detectors in underground laboratories and observations of the behavior of galaxies and galaxy clusters. For example, experiments like Lux Zeppelin and Xenon 1T are aimed at detecting WIMPs, while observatories like the Large Hadron Collider also search for signs of these particles in high-energy collisions. However, despite numerous efforts, direct detection of dark matter has not yet occurred, and its nature remains one of the greatest mysteries in modern science. Even more mysterious than dark matter is the phenomenon known as dark energy. This unknown form of energy is responsible for the accelerated expansion of the universe. Dark energy constitutes about 68% of the total mass energy content of the universe, making it the dominant component of the cosmos. The discovery of the universe's accelerated expansion in 1998, made through observations of Type Ia supernovae, was one of the most important findings in modern cosmology. Scientists were stunned to find that the universe was not only expanding, but doing so at an increasingly faster rate. This discovery led to the introduction of the concept of dark energy. Introduced by Einstein in his equations of general relativity, the cosmological constant describes the energy of the vacuum, which causes the universe's expansion to accelerate. Einstein originally introduced this concept to explain a static universe, but later discarded it, calling it his greatest blunder. However, with the discovery of the universe's accelerated expansion, the idea of the cosmological constant was revived and became a central element of modern cosmology. Another hypothesis suggests the existence of a dynamic field, analogous to the scalar field in physics, that evolves over time and could explain the observed acceleration. This field, known as quintessence, could vary its energy density over time, allowing scientists to explain not only the acceleration, but also its possible changes in the future. Some scientists propose that explaining the accelerated expansion requires revisiting the laws of gravity, such as the theory of relativity. These modifications might include adding new parameters or introducing additional dimensions, which could change our understanding of gravity on large scales. Understanding the nature of dark energy remains one of the biggest unresolved challenges in physics and cosmology. Answers to these questions could lead to a fundamental change in our understanding of the universe and its evolution. For example, if dark energy continues to accelerate the universe's expansion, it could lead to a scenario known as the Big Rip, where galaxies, stars, planets, and even atoms are torn apart by the ever-increasing rate of expansion. Conversely, if dark energy changes its properties over time, it could lead to a slowing or even reversal of the universe's expansion. Study of dark energy is also connected to other fundamental questions, such as the nature of the vacuum and quantum gravity. Discovering and understanding dark energy could provide keys to resolving these problems and lead to the creation of new physics beyond current theories. Thus, black holes, dark matter, and dark energy remain some of the most mysterious and important objects of study in modern science. They force us to rethink how little we know about the universe and drive us to seek new answers and solutions. These cosmic mysteries not only open new horizons of knowledge, but also challenge our understanding of the most fundamental laws of nature. Ultimately, unraveling these mysteries may lead to a new perspective on the universe and our place within it. Cosmology is not only a science, but also a field rich in philosophical reflections, questions about the nature of time and space, the finiteness or infiniteness of the universe, and its possible beginning and end extend beyond traditional science and require contemplation on a deeper level. These questions compel us to think not only about how the universe is structured, but also about the very nature of reality and our place in this grand cosmic order. In this chapter, we delve into the philosophical aspects of time, space, and the anthropic principle, which have continued to intrigue scientists and philosophers for centuries. The question of the nature of time has always captivated the minds of both scientists and philosophers. In everyday life, we perceive time as linear. The past, present, and future follow one another in a strict sequence. This perception of time as something that constantly moves forward is deeply ingrained in our thinking and culture. We measure time with clocks and calendars associated with events and actions, and it has a profound influence on our lives. But is this really how time works? Is time truly linear, or is this just one of its possible manifestations? Modern physics offers various perspectives on the nature of time. In Einstein's theory of relativity, time and space are interconnected in a single space-time continuum, where time can slow down or speed up, depending on the velocity of movement and gravity. This phenomenon, known as time dilation, has been experimentally confirmed in numerous experiments and observations. For example, time on moving spacecraft or near massive objects like black holes flows more slowly compared to time on Earth. This discovery fundamentally altered our understanding of time and its passage, revealing that time is not absolute but depends on the conditions under which it is measured. However, the question remains whether time is linear or if it could be cyclical. Some cosmological models suggest that the universe might undergo cycles of expansion and contraction, leading to recurring big bangs and big crunches. In such a model, time has no beginning or end, but represents an infinite cycle. This idea harks back to ancient philosophical traditions, such as the Hindu concept of yugas, where time is seen as eternal, consisting of endless repeating cycles of birth, death, and rebirth of the universe. Cyclical models of the universe also have modern scientific support. For example, the Big Bounce theory proposes that the universe might experience alternating phases of expansion and contraction. According to this theory, after each big crunch, the universe expands again, which could be interpreted as a new Big Bang. In this model, time could indeed be cyclical, and the current cycle of our universe is just one of an infinite number. Philosophical and religious traditions also offer various views on the nature of time. For instance, in some Eastern philosophies, time is considered an illusion or a phenomenon linked to human perception rather than objective reality. Such concepts challenge the linear perception of time and suggest more complex, multi-dimensional representations of its nature. Understanding the nature of time remains one of the most profound and complex questions in both physics and philosophy. Answers to this question could fundamentally change our understanding of the universe and our place within it. Space, like time, is one of the fundamental components of our perception of the universe. But what exactly is space? Is it infinite, or does it have boundaries? These questions have intrigued scientists and philosophers from ancient times to the present day. We perceive space as something that surrounds us, within which we exist and move. However, when it comes to cosmic scales, our understanding of space becomes far more complex and less certain. According to general relativity, space is curved by the influence of matter and energy. This means that in the presence of massive objects like stars and galaxies, space contracts and stretches. We perceive this curvature as gravity, and it determines how objects move through the cosmos. For example, the orbits of planets around the Sun result from the curvature of space caused by the Sun's gravity. But what does this mean for the nature of space itself? The question remains, is the space of the universe infinite, or is it limited? Modern observations suggest that the universe might be flat on scales exceeding billions of light years. This implies that space might indeed be infinite, continuing in all directions without any boundaries. However, even if space is infinite, this does not rule out the possibility of it being curved and closed. For example, if space has a finite size but no edges, similar to the surface of a sphere, it could mean that by traveling in one direction long enough, we would eventually return to our starting point. Such a model of closed space has been proposed in some cosmological theories, where the universe has a finite volume but no boundaries. The question of the infinity or finiteness of space also has deep philosophical implications. The infinity of space raises questions about the nature of reality, about how we can conceptualize and measure something that has no boundaries. On the other hand, the idea of finite space makes us ponder what might lie beyond its limits, if such limits exist. These questions touch not only on physics, but also on metaphysics, prompting reflections on the nature of existence and what lies beyond our perception. Moreover, the idea of multidimensional space, suggesting the existence of additional dimensions beyond the three we know, is also discussed in the context of string theory and other modern physical theories. These additional dimensions might be curved or compactified at the microscopic level, making them inaccessible to our perception, but they could play a crucial role in fundamental processes occurring in the cosmos. Thus, the question of the nature of space remains one of the most complex and mysterious topics in modern science and philosophy. Answers to this question could not only change our understanding of the universe, but also open new horizons for research and reflection. One of the most remarkable facts about the universe is that it seems fine-tuned for the existence of life. This observation led to the formulation of the anthropic principle, which asserts that the physical laws and constants of the universe are such that they allow for the existence of intelligent beings capable of observing this universe. This principle has sparked numerous scientific and philosophical debates and raises questions about the nature of reality and our place in it. This principle states that we observe the universe as it is because only in such a universe could we exist. In other words, the physical laws and constants of the universe determine the possibility of intelligent observers, and this is not a coincidence, but an inevitable consequence of our existence. A more radical version asserts that the universe must be such that intelligent observers can exist within it. This version suggests that the existence of life and intelligence is not merely a coincidence, but a fundamental purpose or property of the universe. The anthropic principle raises important philosophical questions. It challenges the idea that our universe is just one of many possible universes and suggests that it should be considered special or even unique. At the same time, it opens the possibility that there are countless other universes with different physical laws where life cannot exist. This leads to the idea of the multiverse, the concept that there are countless universes, each with its unique properties. Some scientists consider the anthropic principle trivial, as it simply states the fact of our existence. From their perspective, we observe the universe as it is, because otherwise we wouldn't be here. However, others see in this principle a profound explanation for why the universe has certain properties, such as the value of the cosmological constant or the relationship between fundamental forces. The anthropic principle also raises philosophical questions about the nature of reality and why our universe has the specific physical laws it does. If there are other universes with different physical laws, what makes our universe so special? This leads to reflections on whether there is a higher purpose or design behind the structure and evolution of the universe. Moreover, the anthropic principle can be linked to the concept of the fine-tuning of the universe. This idea suggests that many physical constants and laws are tuned in such a way as to allow for the existence of life. For example, if the strength of gravity or the electromagnetic interaction were slightly stronger or weaker, stars, planets, and life as we know it would not exist. This prompts us to consider whether this fine-tuning is the result of chance, necessity, or some intentional process. The anthropic principle also challenges our understanding of reality and the scientific method. If we live in one of countless universes where the laws of physics happen to align in such a way as to allow for the existence of life, it could cast doubt on our ability to understand and explain the reasons for these laws. Some philosophers argue that the anthropic principle may require us to reconsider our approach to scientific inquiry and our understanding of the universe. Thus, the anthropic principle presents an important philosophical challenge that forces us to rethink our place in the universe and the nature of reality itself. It opens new horizons for contemplating why the universe is the way it is and what our role is in this vast cosmic order. Ultimately, the anthropic principle may lead us to a new understanding of existence and the nature of the universe, as well as a deeper awareness of our role within it. The question of the universe's future is one of the most fascinating and simultaneously terrifying inquiries. What awaits us and the universe in the distant future? Will it exist forever, or is it destined to end? These questions intrigue not only scientists, but also anyone who contemplates our place in the universe and what ultimately lies ahead. Modern cosmology presents several scenarios for the possible future of the universe, each based on our current understanding of physical laws and observations. There are several scenarios for the possible end of the universe, each grounded in contemporary cosmological models and our understanding of the behavior of matter, energy, and space-time. These scenarios describe potential paths by which the cosmos may evolve or conclude its existence, raising profound philosophical and scientific questions. The Big Rip scenario suggests that the accelerated expansion of the universe, driven by dark energy, will eventually lead to the tearing apart of all structures in the cosmos. In this scenario, dark energy becomes an increasingly dominant force, gradually overcoming the gravitational and other forces binding galaxies, stars, and planets. First, galaxies will be torn apart, followed by the disintegration of stars and planets, and eventually, even atoms and subatomic particles will be ripped apart. This scenario predicts that the universe will end in a state of infinite expansion and destruction, where no complex structures or matter remain, leaving behind an endlessly stretched void. In contrast, the Big Crunch scenario envisions the universe's expansion slowing down and eventually reversing into a contraction. This scenario posits that at some point, gravitational forces will overcome the effects of dark energy, causing the universe to begin collapsing in on itself. All galaxies, stars, and planets will draw closer together, ultimately leading to the concentration of all matter and energy into a single point, a singularity. This process could result in a new Big Bang, initiating the birth of a new universe. Some models suggest that the universe might undergo such cycles repeatedly, with expansion and contraction alternating in a continuous cycle of rebirth. The heat-death scenario, also known as the thermal death of the universe, suggests that the universe will continue expanding without any major catastrophes. In this scenario, dark energy will keep accelerating the universe's expansion, but not to the point of tearing apart galaxies and stars. However, eventually, all available energy will be evenly distributed, and the universe will reach a state of maximum entropy. All stars will burn out, cease shining, and star formation will come to an end. The universe will become a cold and dark cosmos, with no available energy left to do work. In this dead cosmos, only weak radiation and scattered elementary particles will exist, drifting through infinite space. This scenario is a variant of heat death, where the universe continues to expand until its temperature approaches absolute zero. Galaxies gradually move away from each other, stars burn out, and space becomes a cold and empty void, where processes that support life and complex structures can no longer occur. This slow fading and freezing of the universe leads to its final death, when there is no energy left for change or motion. The Big Bounce scenario proposes that the universe may undergo cyclical phases of expansion and contraction. After a phase of contraction, when the universe reaches maximum density, a new Big Bang occurs, initiating a new cycle of expansion. This model suggests an infinite alternation of birth and death phases for the universe, with each new universe potentially having its own unique physical laws and parameters. This scenario also raises questions about the nature of time and space, viewing them as cyclical rather than linear phenomena. These scenarios of the universe's end open up not only scientific but also philosophical reflections on the nature of time, space, and existence. Regardless of which scenario proves correct, each serves as a reminder of the fragility and impermanence of the cosmic order in which we exist. Alongside contemplating the fate of the universe, we must also consider humanity's future. What role will we play in cosmic evolution, and what future awaits us in this vast universe? If one day our planet becomes uninhabitable, or if some cosmic catastrophe threatens its existence, will we be able to colonize other planets and star systems? These questions already occupy the minds of scientists, philosophers, and explorers, and the answers may determine the fate of our species. At present, Interstellar travel seems far from reality, but research and development in space technology continue. Missions to Mars, the construction of space stations, and the development of new propulsion systems could lay the foundation for humanity's future as a spacefaring civilization. Programs like Elon Musk's Mars Architecture project, which envisions the colonization of the Red Planet, or NASA's plans to return to the Moon and establish a lunar base, are the first steps toward exploring the solar system. However, interstellar travel presents an even greater challenge. Crossing the vast distances between stars requires technologies that we do not yet possess. Nevertheless, scientific research continues, and concepts such as star sails, the use of antimatter, or the warping of space-time, the warp drive principle, may one day make interstellar travel a reality. Space expansion also requires consideration of ethical and philosophical questions. How will we interact with possible extraterrestrial life? If we discover microorganisms or intelligent beings on other planets, what will our moral and ethical obligations to them be? Should we colonize other worlds or leave them untouched, respecting a cosmic right to inviolability? These questions necessitate the development of new approaches to international law and space policy. How will society be organized on other planets? Will we be able to transplant our earthly social structures into space, or will they need to change in response to new conditions? A spacefaring society may face unique challenges, such as the need for self-sufficiency, coping with radiation, microgravity, and long-term isolation. At the same time, space offers new opportunities for social and technological progress, which could transform the very concept of society and the state. Should we strive for the stars, or should we focus on solving problems on Earth? Some philosophers and ecologists argue that before expanding into space, humanity must learn to resolve its issues on its home planet. Environmental crises, social inequality, and political conflicts demand urgent attention and solutions. However, others believe that space exploration could provide a new impetus for human development, inspiring innovation and creating new resources and opportunities for survival and prosperity. Humanity's future in space is also tied to questions of the meaning and purpose of our existence. Is our destiny to explore and colonize space, or should we find meaning in preserving and developing our own planet? These questions require deep reflection and decisions that will determine not only our fate, but the future of all living things. In conclusion, reflections on the cosmic future and the fate of the universe lead us to realize that our lives and actions have significance not only for ourselves, but for the entire cosmos. Whatever the future holds, it is essential to remember that our existence is part of a grand cosmic process, and we bear the responsibility to use our knowledge and resources wisely and responsibly. When we speak about our place in the universe, we cannot avoid the question of the legacy we will leave behind. Humanity has always sought to leave its mark on history, whether through art, science, or great achievements. But what mark will we leave on a cosmic scale? How will our cultural and scientific legacy be preserved and passed on when we are no longer here? These questions provoke deep reflection on how our actions today can influence the distant future and the legacy we will leave for future generations and possibly other intelligent beings in the universe. One of the most famous symbols of humanity's legacy in space is the golden records sent aboard the Voyager 1 and Voyager 2 spacecraft in 1977. These spacecraft were designed to explore the outer planets of the solar system, but their mission includes something far more symbolic. The golden records were conceived as messages that might be discovered and understood by extraterrestrial civilizations billions of years from now. These records contain sounds and images from Earth, including greetings in 55 languages, musical compositions from various cultures, and images of our planet and its inhabitants. Among the sound recordings are sounds of nature, laughter, whale songs, and excerpts from works by Bach, Mozart, Stravinsky, and other composers. Every detail was carefully thought out to convey the essence and beauty of life on Earth. These records serve as a kind of time capsule, carrying information about who we are and how we see the world. The idea of these records reflects a profound desire for humanity to connect with something greater than itself. They symbolize our longing to be understood, our hope that somewhere out there, beyond the solar system, there exist intelligent beings who can comprehend and appreciate our culture and achievements. Even if these messages are never discovered, they remain a symbol of our human nature, the drive to explore, to connect with others, and to seek meaning in the vast expanses of space. The Golden Records also raise important questions about the nature and significance of our legacy. What do we choose to pass on to future generations or extraterrestrial civilizations? What will be considered important and valuable billions of years from now? These questions compel us to think about how we define and value our cultural and scientific heritage, and how our decisions today may impact the future. In addition to material objects like the Golden Records, humanity has also sent radio signals into space in hopes of contacting other civilizations. One of the most famous such signals was sent in 1974 from the Arecibo Observatory. This Arecibo message contained encoded information about the human race, our solar system, and key chemical elements. The signal, a powerful radio burst, was aimed at the star cluster M13, located about 25,000 light-years from Earth. While the likelihood that the signal will reach its intended recipient is extremely small, this act reflects our desire to establish contact with other intelligent beings. We seek not only knowledge and understanding, but also a connection with others who share our ability to comprehend the universe and strive for knowledge. This desire for contact reflects our nature as social beings who crave communication, even if that contact might be with beings about whom we know nothing. However, these actions are not without philosophical questions. Should we attempt to contact potentially more advanced civilizations? What consequences might this have? Some scientists, like Stephen Hawking, warned that actively sending signals into space could be dangerous, as we do not know the intentions of those who might receive them. These warnings are based on historical experiences where encounters between civilizations with different levels of development on Earth often led to destructive consequences for the less advanced societies. Nevertheless, despite these concerns, many scientists continue to support the search for extraterrestrial intelligence programs, believing that the potential reward, establishing contact with another intelligent life form, justifies the risk. These programs include both active signal sending and passive listening to space for artificial radio waves. If we ever establish contact, it could become the most significant event in human history, capable of transforming our understanding of the universe and our place in it. The question of colonizing other planets is one of the most discussed topics regarding humanity's future. If Earth becomes uninhabitable due to climate change, resource depletion, or other global catastrophes, could we find a new home among the stars? The most likely candidate for the first human colony is Mars, a planet that has long attracted the attention of scientists and explorers due to its relatively favorable conditions. But colonizing Mars is not just a technical challenge. It raises questions about what it means to be human in a completely alien environment. How will our society change when people start living on another planet? How will our social, political, and economic structures adapt to conditions where resources are limited and survival depends on collective effort? These questions require not only scientific, but also philosophical reflection. Colonizing other worlds also raises questions about our approach to new territories. Can we learn from history and avoid the mistakes of the past, when colonization on Earth often led to the destruction of ecosystems and cultures? How will we interact with possible extraterrestrial life if it is discovered? Is there an ethical obligation to preserve and protect other worlds from interference? Space colonization could become one of humanity's greatest adventures, but it also demands a responsible approach. We must understand that expansion into space is not just the continuation of exploring new territories, but also an opportunity to rethink our values and priorities. Instead of repeating the mistakes of the past, we have the chance to create a new, just, and sustainable society based on respect for nature and life. Moreover, there is the question of what cultural and spiritual legacy future space colonists will carry. How will their perception of the world and their place in it change when they live on other planets or in space stations millions of kilometers from Earth? These people will have to adapt to a new reality where familiar earthly landmarks and symbols may lose their significance. They may need to create new forms of culture and religion that reflect their unique experience of life in space. In the context of reflecting on our cosmic legacy, we cannot ignore our home, planet Earth. Despite all our dreams of the stars, our planet remains the only known place in the universe where life can exist as it does now. And this life is extraordinarily fragile. Earth, as numerous studies and observations have shown, is a unique oasis of life. In the vastness of space, surrounded by void and hostile conditions, space reminds us of Earth's fragility and uniqueness. In the vastness of space, Earth is a tiny oasis of life, surrounded by a hostile void. This view from space, especially iconic images of Earth like the pale blue dot, reveals how vulnerable our world is. We realize that our planet is a thin layer of the biosphere supporting all living things, and this layer can be destroyed by our actions. This realization should inspire us to take greater care of our planet and each other. Preserving Earth is not just an ecological task, but a moral obligation. Our cosmic legacy will be defined by how we treat this home and one another. Will we be able to preserve and pass on a planet capable of sustaining life to future generations? Or will we leave behind a devastated ecosystem and depleted resources? Space also teaches us humility and responsibility. Realizing that Earth is our only home in the vastness of space should inspire us to adopt a more responsible approach to our impact on the environment and our role on a cosmic scale. Ultimately, our cosmic legacy will be defined not so much by what we leave behind in space, but by how we care for our common home, planet Earth. When we contemplate the future, we must not only consider the coming decades or centuries, but also look forward to millennia. On this scale, possibilities that seem fantastical today may become reality. The cosmic age we are just beginning to grasp represents not merely a new chapter in human history, but an era that could fundamentally alter our understanding of ourselves and our place in the universe. This future will require not only technological achievements, but also deep philosophical and cultural reflection on our path in space. The idea of interstellar travel has long been the subject of science fiction, but today, scientists seriously consider the possibility of creating interstellar ships. The challenges associated with such journeys are immense. The distances between stars are measured in light years, necessitating the development of technologies capable of achieving incredible speeds or sustaining life over multiple generations. However, projects like Breakthrough Starshot, aimed at developing technologies to send miniature probes to the nearest stars, offer hope that interstellar travel could become a reality in the foreseeable future. Breakthrough Starshot is one of the most ambitious initiatives in this field. The project plans to use ultralight nanosatellites equipped with light sails that will be propelled by powerful laser beams from Earth. This approach allows for achieving a significant fraction of the speed of light, enabling the probes to reach Proxima Centauri in just a few decades. Although the technical and financial challenges remain enormous, the successful implementation of such a project would open new horizons for our species. Creating a fully functional interstellar ship capable of carrying a crew and sustaining life during long journeys requires the development of entirely new technologies. We may face the need to solve fundamental issues such as ensuring long-term autonomy, protecting against cosmic radiation, and creating closed ecosystems capable of supporting life for centuries. We might need to develop generation ships, where multiple generations of people will be born and live before reaching their destination. If humanity ever succeeds in creating ships capable of traversing interstellar distances, it will open new horizons for our species. We will be able to begin exploring other star systems, searching for new worlds to colonize, and possibly establishing contact with other intelligent civilizations. However, these achievements will require not only technological progress, but also global cooperation, international efforts, and vast resources to turn these dreams into reality. In the long term, humanity may strive to explore and colonize deep space. This includes not only the colonization of other planets in our solar system, such as Mars and the moons of Jupiter and Saturn, but also the exploration and settlement of other star systems. Such projects will require enormous resources and scientific breakthroughs, but they could become a reality in the distant future. The exploration of deep space will require humanity to adapt to new, unknown conditions. This may mean not only technical preparation, but also evolutionary changes. We may need to adapt our bodies to conditions of microgravity or extreme climate conditions on other planets. Additionally, the exploration of deep space will necessitate the development of new forms of social organization that can maintain social and cultural stability in conditions of long-term isolation and autonomy. The exploration and settlement of other star systems may also require changes in our worldview. How will our self-identification change when we live in societies existing on different planets and in different star systems? How will we interact and exchange knowledge and cultural achievements across vast distances? This may lead to the emergence of new forms of interstellar diplomacy and international space law. The exploration of deep space also raises questions about our moral and ethical obligations. If we discover life on other planets, how will we interact with it? Will we be able to preserve and protect new worlds from our interference, or will we seek to alter them? These questions require deep philosophical reflection and the development of new approaches to our role in space. One of the key aspects of humanity's future in space may be the use of biotechnology and artificial intelligence to expand our capabilities. Space represents an extremely hostile environment for humans. Radiation, extreme temperatures, the absence of atmosphere and gravity make prolonged stays in space dangerous to health. Biotechnology could offer solutions to these problems, such as genetic modification to adapt our bodies to space conditions, or the use of synthetic biology to create sustainable ecosystems on other planets. Moreover, artificial intelligence, AI, could play a crucial role in managing complex space missions, especially in situations where humans cannot participate directly due to hazardous conditions or the duration of journeys. AI could be used for the autonomous operation of spacecraft, the exploration of new planets, and the support of colonies, ensuring their safety and functioning. However, as with any new technology, the use of AI raises important ethical questions. How will we control and manage these technologies? What will happen if AI goes beyond our control? These technologies also raise important questions about what it means to be human. How will our consciousness and society change if we can modify ourselves and create artificial beings? How will we define the boundaries between natural and artificial, between human and machine? In the future, the concept of humanity may expand to include not only biological beings, but also synthetic life forms that coexist with us or even within us. The transformation of humanity also touches on cultural and social aspects. How will we preserve our culture and traditions if we begin to alter ourselves? Will we be able to maintain our values and identity, or will we need to reconsider them in light of new possibilities and challenges? These questions will play a key role in defining our future as a species and as a spacefaring civilization. Alongside scientific and technological progress, our cultural and spiritual development must also keep pace with expanding horizons. The cosmic age will require new philosophical and spiritual paradigms that help us understand our place in the universe and our connection to the cosmos. As we begin to leave Earth and venture into space, it is important to recognize that this journey is not only physical, but also spiritual. The cosmic age poses new questions about the meaning of life and what it means to be human on a cosmic scale. How will we perceive ourselves and our goals when we realize that we are just one of many possible forms of life in the vast universe? What cultural and spiritual values will be important in a world where interstellar travel becomes a reality? We may need to rethink our concepts of the divine, the meaning of existence, and our role in the cosmos. The cosmic age may also lead to the emergence of new forms of religion and spirituality. How will religious concepts be perceived in the context of space life? Will we be able to maintain our spiritual traditions, or will they be transformed under the influence of new knowledge and experiences? We may see the emergence of cosmic religions that reflect our new understanding of the cosmos and our place in it. Culture and art will also play a significant role in the cosmic age. How will we express our feelings and thoughts in a world where our perception of the universe expands beyond Earth? What new forms of art and literature will arise under the influence of the space experience? The cosmos may inspire us to create new artistic and literary genres that reflect our journey through the universe and our attempts to comprehend it. Additionally, the cosmic age will require new approaches to education and upbringing. How will we prepare new generations for life in space? What knowledge and skills will be important in a world where interstellar travel becomes a reality? We may need to create new educational systems that take into account the needs and challenges of space life. The cosmic age opens not only new opportunities, but also new challenges for humanity. It requires not only technical preparation, but also profound cultural, spiritual, and philosophical reflection on our path. We will need to rethink our values and goals to create a society capable of thriving in space while preserving its cultural and spiritual heritage. A look into the future is not just about predicting technologies and scientific achievements. It is also about understanding how our cultural and spiritual development will shape our future in space. We stand on the threshold of a new era, and it is up to us to determine what that future will be. Will it be based on respect, wisdom, and cooperation, or will we repeat the mistakes of the past, taking them to a new level? The answers to these questions will define not only the future of humanity, but also our cosmic legacy. One of the most thrilling aspects of modern cosmological theories is the idea of the multiverse, a concept suggesting the existence of multiple parallel universes, each with its own set of physical laws and parameters. If this theory is true, then our universe is just one among countless others, and its unique characteristics may be merely a coincidence amid infinite variations. This hypothesis not only opens new horizons of understanding, but also challenges our fundamental notions of reality and existence. The theory of the multiverse represents an expansion of our understanding of the cosmos. Where once it was believed that our universe was singular, some scientists now propose that there exists an infinite number of universes forming a multiverse. These universes might differ from one another in various ways, from subtle differences in physical constants to radically different structures of space-time. The question of what the multiverse is transcends traditional cosmology, touching on quantum mechanics and theoretical physics. The theory of inflation suggests that in the early universe, there was an extremely rapid expansion that could have led to the formation of multiple bubbles of space-time, each of which evolved into a separate universe with its own physical laws. These bubble universes might be connected only through their common origin in the inflationary phase. This opens the possibility of the existence of local universes, each with unique parameters and laws. In this case, our universe is just one of many formed as a result of the inflationary process. In string theory, one of the leading candidates for a theory of everything, there may be a situation where there are vast numbers of different vacua with varying physical properties, each capable of generating its own universe. This landscape of vacua allows for the existence of numerous possible configurations of universes, each with its own physical laws. String theory offers a picture in which our universe is just one of many possible realizations, each unique and potentially existing in its own space-time. These hypotheses open new horizons for understanding the nature of reality and present challenges for science in terms of testing and confirming the existence of the multiverse. Despite the lack of direct evidence, these theories offer exciting possibilities for future research and contemplation. If the multiverse exists, it raises the question, why does our universe have exactly the physical laws that allow life to exist? In this context, the anthropic principle takes on renewed significance. Perhaps our universe is one of the few where physical parameters are fine-tuned to allow for the formation of stars, planets, and life. In other universes, the forces of interaction, or constants, might be such that matter cannot exist in stable forms, or there might be entirely different forms of matter and energy that we cannot even imagine. The anthropic principle, viewed in the context of the multiverse, might explain the unique properties of our universe as a result of random selection among countless possible universes. In this case, the physical laws and constants that seem fine-tuned for the existence of life may simply be one of many possible combinations, and only in those universes where these laws and constants allow for intelligent life can observers arise who contemplate the nature of their universe. This variability challenges us to reconsider what reality is and what its possible forms could be. If the physical laws we consider fundamental are just one of many possible configurations, what defines reality in other universes? What might these realities look like, and what forms of life and consciousness could exist within them? These questions transcend traditional physics and require philosophical reflection. Moreover, the variability of physical laws in the multiverse might suggest that our understanding of fundamental principles of physics is not universal. The laws we take as the foundation of science may be local rules that apply only within our universe and are not applicable to other universes with different physical parameters. This opens up the possibility of alternative physics and realities that remain beyond our current understanding. The idea of the multiverse has not only scientific, but also profound philosophical implications. If infinite parallel universes exist, then in one of them, every possible fate of ours is already realized. This challenges traditional notions of free will, karma, and even moral responsibility. If our actions are merely one of countless possible outcomes, then in what sense are they meaningful? How can we speak of free choice if every possible choice is already realized somewhere? On the other hand, the awareness of the existence of multiple universes can lead to new ethical and philosophical questions. How should we perceive and value our lives and actions if they are merely one of countless possible variations? Perhaps our focus should not be on trying to understand the meaning of life on a global scale, but on making our reality as kind and just as possible. This awareness might lead to a re-evaluation of our ideas about the value of life and the meaning of existence. Furthermore, the idea of the multiverse raises questions about moral responsibility and the consequences of our actions. If every mistake and every success of ours is already realized in another universe, how should we evaluate the consequences of our actions? These reflections might lead to new approaches in ethics that take into account the diversity of possible worlds and realities. Philosophical questions also touch on our identity and self-perception. If in every parallel universe there exists a version of ourselves that differs only in details, what makes us unique? Where does I end and the other begin? These questions challenge traditional concepts of selfhood and require a re-evaluation of our understanding of identity in the context of the multiverse. Research into the multiverse is at the forefront of modern science, but it also faces significant challenges. How can we confirm the existence of other universes if they may never interact with ours? Can a theory that is essentially untestable be considered scientific? These questions provoke active debate among scientists and philosophers. Some argue that the theory of the multiverse lies beyond traditional science, as it cannot be experimentally confirmed. In the absence of direct evidence, the idea of the multiverse might be regarded as a philosophical concept rather than a scientific hypothesis. However, other scientists contend that the multiverse is a logical consequence of certain theories, such as string theory and cosmological inflation, and therefore deserves serious attention and study. The answers to these questions may require a re-evaluation of our ideas about science and its methods. In the future, science might focus more on theoretical models and abstract concepts that go beyond observable reality. This could necessitate the development of new scientific methods capable of accommodating hypotheses that are not directly testable. Such changes could fundamentally alter our understanding of what science is and how it should function. Moreover, the exploration of the multiverse could lead to new discoveries that fundamentally change our understanding of the universe and our place in it. If the multiverse hypothesis is confirmed, it will offer a new perspective on the nature of reality, expanding our ideas about possible worlds and forms of existence. It could also provide us with new tools for exploring fundamental questions in physics, such as the nature of time, space, and matter. The multiverse represents one of the most ambitious and fascinating ideas in modern science. It opens up endless horizons for research and reflection, challenges our notions of reality and existence, and offers new pathways for the development of science and philosophy. Regardless of how research in this area evolves, one thing is clear: the idea of the multiverse will continue to inspire scientists and philosophers for many years, remaining one of the most enigmatic and intriguing concepts of our time. The human mind is a remarkable tool that enables us to explore and understand the universe. Yet, despite our achievements, many aspects of the cosmos remain beyond our grasp. In this chapter, we will examine how the human mind interacts with the cosmos and how our perception and thinking can shape our future. The vastness and mysteries of the cosmos have always inspired humanity to make great discoveries, generate new ideas, and engage in philosophical reflection. Our interaction with the cosmos not only expands the boundaries of knowledge, but also transforms us, prompting us to rethink our place in the world and our understanding of reality. When we begin to comprehend the vastness of the universe, it profoundly impacts our consciousness. The sight of Earth from orbit, the discovery of distant star systems, and the realization that we are but a small part of an immense cosmos all alter our worldview. This awareness, often referred to as cosmic consciousness, has a powerful influence on our thinking and perception of reality. Cosmic consciousness is not just an intellectual understanding that we live in a vast and complex universe, but also a deep inner experience that can change our worldview. This feeling is often associated with the concept of the overview effect, a phenomenon described by astronauts who first saw Earth from space. They experienced intense emotions linked to the realization of the unity of all life on the planet and the fragility of our world. This experience can lead to a shift in priorities, reinforcing a sense of responsibility toward the planet and life as a whole. Cosmic consciousness also fosters global thinking and a deeper understanding of our role in the cosmic context. When we see Earth as a small blue dot in the vastness of space, it helps us realize that the boundaries dividing nations and states are ultimately illusory. We are all part of one world, one planet, and our future depends on our ability to cooperate and live in harmony with nature and each other. Moreover, cosmic consciousness encourages philosophical reflection on the meaning of life and our role on a cosmic scale. The awareness that we live in an immense and ancient universe can inspire the search for new answers to age-old questions about the nature of existence, destiny, and purpose. This may lead to the emergence of new philosophical directions that take into account the cosmic dimension of our existence. The development of artificial intelligence has opened new horizons in space exploration. Complex tasks, such as processing vast amounts of data or managing robotic probes in the distant reaches of the solar system, are made possible by AI. Today, AI is already being used to analyze data from space telescopes and probes, automatically plan missions, and even make real-time decisions when communication with Earth is impossible due to vast distances. AI has the potential to significantly accelerate the process of discovering new knowledge about the universe. For example, machine learning systems can analyze data collected over years of observations and detect patterns that may have escaped human attention. This opens new possibilities for discovering exoplanets, studying cosmic objects, and understanding complex processes occurring in galaxies and beyond. However, AI also raises questions about the future of the human mind. If we create machines capable of thinking and making decisions on par with humans, how will this change our perception of ourselves and our place in the cosmos? The question of what it means to be an intelligent being becomes particularly relevant if AI reaches a level where it can independently explore and understand the cosmos. This scenario raises questions about whether such AI represents a new form of intelligence with its own goals and desires, or whether it remains merely a tool in human hands. Could AI help us reach new heights in space exploration, or will it become a new form of intelligence that competes with humans? These questions concern not only science and technology, but also ethics. If AI can develop its own consciousness and make autonomous decisions, should we recognize its right to independent existence? How will the relationship between humans and AI be regulated in the future when both work side by side in the exploration of space? Furthermore, the development of AI in the space field may change our approach to understanding the universe. Instead of relying solely on human perception and thinking, we could use AI to explore aspects of the cosmos that lie beyond our natural capabilities. This could lead to the creation of new forms of knowledge and understanding based on the synergy between the human mind and artificial intelligence. The cosmos has always been a source of inspiration for artists, writers, and musicians. The sight of endless starry expanses or reflections on other worlds compels people to create works of art that express our wonder and admiration for the cosmos. From ancient times, myths and legends about celestial bodies have inspired creativity, and modern artists continue to explore the theme of the cosmos in their works, creating paintings, sculptures, films, and literary pieces that convey the grandeur and mystery of the universe. Modern technology allows us to create virtual universes, which can become a new form of art. Virtual reality, 3D modeling, and other innovations enable artists to bring their cosmic fantasies to life in new forms, expanding the boundaries of our perception and inspiring new discoveries. Virtual universes allow viewers to immerse themselves in cosmic worlds, travel among stars and planets, and experience emotions that were previously accessible only through imagination. The cosmos also influences music. Composers and musicians create works inspired by the sounds and images of the cosmos, using new technologies to create soundscapes that convey the sense of infinity and mystery of the universe. These compositions can incorporate both traditional instruments and electronic music, creating new forms of sonic art that reflect our desire to understand and explore the cosmos. Literature also plays a significant role in exploring the cosmos through art. Science fiction, inspired by cosmic themes, allows authors to explore hypothetical worlds and the future of humanity in space. These works not only entertain, but also raise important questions about science, technology, ethics, and philosophy. They inspire reflection on how the cosmos might change our society and our perception of reality. Art inspired by the cosmos can also serve as a bridge between science and the general public, helping to popularize space exploration and making it more accessible to a wider audience. Visual and auditory works based on scientific discoveries and space missions can inspire a new generation of explorers, scientists, and artists who will continue to seek answers to the great questions of the universe. Philosophy has always played a crucial role in understanding our existence in the universe. Questions about the nature of time, space, consciousness, and the meaning of life become even more relevant as we explore the cosmos. Cosmology and quantum physics raise questions that go beyond traditional philosophy and require new approaches and paradigms. One such question is the nature of reality. Cosmological theories, such as the multiverse or quantum superposition, challenge our traditional ideas of what reality is. Perhaps what we perceive as reality is merely one of many possible worlds or states existing in parallel. This raises questions about what it means to exist and what forms of reality might be possible. Moreover, the exploration of space raises questions about our identity and place in the world. If we are merely one of countless forms of life in the vast universe, what does this say about our uniqueness and significance? How can we make sense of our existence in the context of the cosmic scale? These questions require a rethinking of the concepts of self and we in light of our discoveries about the universe. Space exploration also opens new horizons for the philosophy of consciousness. How are our consciousness and the universe connected? Is our perception of the cosmos a subjective reflection of our mind, or does it reflect an objective reality that exists independently of us? These questions touch on both the nature of consciousness and the nature of the universe, and require an interdisciplinary approach that includes philosophy, neuroscience, and physics. Questions about the meaning of life also take on a new dimension in light of space exploration. If the universe is infinite and filled with countless worlds, what is the meaning of our existence? Is life on Earth unique, or are there other forms of life with their own meanings and purposes? These questions lead to a re-evaluation of traditional philosophical approaches and the search for new answers that consider the cosmic dimension of our existence. Ultimately, space and philosophy are closely intertwined, as both seek truth and understanding of reality. Cosmic consciousness, artificial intelligence, creativity, and philosophy all interact, creating a new picture of the world in which humanity continues to search for its place and meaning in the vast expanses of the universe. We have reached the end of our journey through the universe and our reflections on our place within it. But this end is merely a beginning. The cosmic perspective we gain by exploring stars and galaxies transforms us. It compels us to ponder our existence, the future of our planet, and the legacy we will leave behind. This journey not only reveals the mysteries of the cosmos, but also leads to a new understanding of ourselves, our place in the world, and what truly matters in life. Humanity will always strive for knowledge and discovery. This quest is not just a scientific endeavor, but a deep, intrinsic desire to understand our place in the cosmos. From ancient times, when people first looked up at the stars, to the present day, when our space probes explore distant planets, we have always been driven by this desire. It is ingrained in our nature, in our quest for knowledge, to understand who we are and where we come from. Space exploration is not just about technology and science. It is also about spiritual development, the reflection on our existence, and our connection to the vast cosmos. This eternal quest brings us to questions that go beyond science. What does it mean to be human in an infinite universe? What role does life play on a cosmic scale? What is consciousness, and how is it connected to the nature of reality? The answers to these questions may not always be found in laboratories or aboard spacecraft. They require deep philosophical reflection and spiritual understanding. Each new discovery, whether it's the detection of exoplanets or the understanding of black holes, adds to our knowledge, but also opens up new questions. This process is endless. The cosmos is full of mysteries, and every time we uncover one, new, even more fascinating and complex ones arise. This eternal quest may never end, but it is precisely this that makes us who we are, beings who cannot remain indifferent to the mysteries surrounding them. This eternal quest also leads us to an awareness of our limits. Despite all our achievements, much remains beyond our comprehension. The cosmos is so vast and complex that we may never fully understand it. But this should not stop us. On the contrary, the recognition of our limitations drives us to even deeper exploration, to an even greater pursuit of knowledge and wisdom. The cosmic perspective shows us that despite all our differences, we all live on one tiny planet, dependent on a star that is just one of billions. This awareness can lead to a deeper understanding of our connection to other people and nature, to the recognition of our shared future. The cosmos, in its grandeur and scale, forces us to think about the unity of all life on Earth. We realize that we are all interdependent on each other and our planet, and that our actions have global consequences. This perspective helps us see that the boundaries between nations and cultures are illusory in the context of the cosmos. We are all part of one human community, living on this small blue planet, which in itself is a rarity in the cosmos. Within this understanding lies the potential for strengthening global cooperation, for creating a society based on mutual understanding and respect, one that considers the interests of all people and future generations. Unity in diversity also pertains to our relationship with nature. Earth is the only known home we have, and its ecosystem supports life in all its forms. The cosmos reminds us of the fragility and uniqueness of our planet. The awareness that we are not just inhabitants of Earth, but also its guardians for the future, can inspire a more responsible attitude towards the environment and encourage us to seek sustainable solutions that will preserve our planet for future generations. Furthermore, the cosmic perspective can help us overcome the conflicts and divisions that exist on Earth. When we see our planet from space, we understand how small and insignificant our differences can be, compared to the global challenges facing all of humanity. The cosmos teaches us that ultimately we are all connected, and our future depends on our ability to cooperate and work together for the common good. We stand on the threshold of a new space age, where humanity will explore not only the solar system, but beyond. This future can bring us great discoveries as well as significant challenges. We are at a point where technological advances allow us to consider the colonization of other planets, journeys to other star systems, and the search for life beyond Earth. These dreams are becoming increasingly realistic, and they open up new opportunities for exploration and the expansion of human presence in the cosmos. However, these opportunities come with significant challenges. How will we use space resources? How will we organize societies on other planets? What ethical norms and principles will guide our actions in space? The answers to these questions will determine not only the future of the space age, but also the fate of humanity. The future of the space age is also connected to questions about our place in the cosmos. How will our self-perception change as we begin to live and work on other planets? How will new living conditions, new technologies, and new discoveries affect us? These questions require deep reflection and preparation, as the space age will change not only our technologies, but also ourselves. The cosmos calls us to the stars, and this call is not just a desire for new discoveries, but also a summons to a greater understanding of our place in this vast universe. We are part of something much greater than ourselves, and understanding this can lead us to a new comprehension of life and our role within it. This new era may become a time of great achievements, but it will also be a time of great trials, requiring from us not only technical expertise, but also wisdom, humility, and a deep understanding of our responsibilities toward future generations. As we conclude our journey, it is important to remember that the cosmic perspective is not just about gazing at the stars. It is a new way of seeing and understanding the world, a way that can transform us and our society, inspire us to great achievements, and help us become better stewards of our planetary home and wise explorers of the cosmos. The cosmos is not just a space we explore. It is a source of inspiration, a place where we find new meanings and new purposes for our existence. Our journey through space is only beginning, and whatever the future holds, it will be shaped by the decisions we make today. Will we use our knowledge and technologies for the common good? Will we strive for peace and cooperation? Or will we repeat the mistakes of the past? The answers to these questions will determine not only our future, but also the future of the cosmos that calls us to the stars. When humanity first ventured beyond Earth's atmosphere, a new era began, not just in science, but in our understanding of ourselves as a species. We realized that our shared home is a small, fragile, and precious blue planet, surrounded by the vastness of space. This realization led to the emergence of the concept of collective consciousness, the idea that despite our cultural, national, and religious differences, we are all part of a single humanity, a unified whole. This concept not only deepens our understanding of unity, but also points the way toward harmonious coexistence and cooperation on a planetary scale and beyond. The view of Earth from space, captured by the astronauts of the Apollo program, had a profound impact on our perception of our place in the universe. This overview effect, the feeling of deep unity and connection with all of humanity and our planet, inspired many to rethink their priorities and values. When astronauts first saw Earth from space, they described it as a tiny, fragile sphere surrounded by emptiness, which evoked a powerful emotional response and deep reflection on the nature of our existence. The cosmic perspective shows us that our differences are insignificant compared to what unites us. The awareness of this unity can become a driving force for addressing global challenges such as climate change, poverty, conflict, and social injustice. When we see Earth as a single organism, our duty to care for it and each other becomes evident. This awareness can inspire us to develop new approaches to global governance, where international cooperation and solidarity prevail over differences and divisions. Awareness of unity on a cosmic scale can also influence our ethical system. How should we treat other forms of life if we discover them in space? How will we regulate the use of space resources to benefit all and not just select groups or countries? These questions require the creation of a new ethics based on principles of respect, responsibility, and justice that apply both on Earth and beyond. Furthermore, cosmic unity can stimulate the development of new forms of cultural exchange and cooperation. When we realize that we are all inhabitants of one planet, this can lead to closer interaction between different cultures and traditions, to mutual enrichment and respect. Space can become a new arena for cultural dialogue, where each culture contributes uniquely to the common good. How will we perceive ourselves and each other when humanity becomes a spacefaring species? A new concept of cosmic citizenship may emerge. The idea that every person is not only a citizen of their country, but also part of a global and, in the future, interplanetary community. This concept is based on the awareness of our shared responsibility for the future of both our planet and the cosmos as a whole. Cosmic citizenship implies accepting responsibility for maintaining peace and cooperation on a planetary scale and even beyond. This new understanding of citizenship requires us to rethink our duties and rights, which extend beyond national borders and encompass the entire solar system and possibly other star systems in the future. We must recognize that our actions have consequences not only for ourselves but for all of humanity, and that our responsibility extends far beyond our planet. Cosmic citizenship also involves new forms of rights and responsibilities. For example, how will we regulate the use of resources on other planets? What rights will colonists on Mars or other planets have? How will we protect the rights of future generations who will live in space? These questions require the creation of new international treaties and agreements that will regulate human activities in space and ensure fair and sustainable development. Moreover, cosmic citizenship opens new opportunities for education and upbringing. We must prepare new generations not only for life on Earth, but also for life in space, teaching them to understand and respect cultural diversity and to be aware of their responsibility to all of humanity. Cosmic citizenship also requires us to develop new forms of international cooperation based on the principles of equality, justice, and respect for the rights of all people, regardless of their origin and place of residence. The cosmic destiny of humanity may be far grander than we can imagine. If we can overcome current challenges and unite to explore space, incredible opportunities await us. We may witness the creation of the first colonies on Mars, the exploitation of asteroid resources, and journeys to other stars. These achievements will not only expand the boundaries of our knowledge and capabilities, but also change our understanding of ourselves and our place in the universe. But our cosmic destiny is not just about technology and exploration. It is also about how we will change as a species, how our thinking, values, and perception of ourselves will evolve. Space opens new horizons for us, and with each new discovery, we will be forced to reconsider our notions of reality, what it means to be human, and our role in the universe. Perhaps in the future, humanity will remember the 21st century as the time when we took the first steps toward becoming a true spacefaring civilization, a civilization that not only strives for the stars, but also understands its responsibility to the universe. This new civilization will be based on principles of sustainable development, respect for nature and life, and the understanding that we are not alone in the universe, and that our destiny is closely linked to the fate of the entire cosmos. The cosmic destiny of humanity also includes the realization of our limitations and vulnerabilities. We must understand that despite our technological achievements, we remain part of nature and are dependent on it. Space reminds us that life on Earth is a rarity and a treasure that must be cherished and protected. Our cosmic destiny depends on whether we can find a balance between technological development and the preservation of our planet and its ecosystems. Furthermore, the cosmic destiny of humanity requires us to be ready for change. Space will constantly present us with new challenges that will require flexibility and adaptability. We will need to develop new forms of society and culture that can meet these challenges and ensure sustainable development in the space age. In conclusion, the cosmic destiny of humanity is not just a journey to the stars. It is a path to a new understanding of ourselves, our place in the universe, and our responsibility to future generations. Space opens up endless possibilities for us, but it also requires wisdom, humility, and a readiness for cooperation. Ultimately, our cosmic destiny depends on whether we can unite as a single humanity to create a future based on the principles of justice, sustainability, and respect for life in all its forms. As space technology advances and our ability to explore and utilize space expands, we are confronted with the need to address the ethical questions associated with these new frontiers. How should we interact with other worlds if we discover life beyond Earth? What responsibilities do we bear for preserving space as an unspoiled environment? These questions become increasingly relevant as we deepen our presence in space. The space age requires us not only to achieve technological milestones, but also to engage in ethical reflection on our actions and their consequences. One of the primary ethical dilemmas revolves around how we should approach potential extraterrestrial life. If we discover microorganisms on Mars, beneath the icy surface of Europa, or on other celestial bodies, how should we interact with them? Questions about whether we should interfere with their natural environment for scientific research or leave them undisturbed become central to the formulation of space ethics. If microorganisms found in space are the first evidence of extraterrestrial life, this will raise serious moral and philosophical issues. Should we consider such life forms as having an inherent right to exist, even if they are not intelligent? How will we protect their habitats from contamination and the impact of our research? These questions demand the development of new ethical principles that take into account the interests of not only humanity but also other forms of life should they exist. Moreover, the ethical dilemma extends to our research methods. To what extent is it acceptable to introduce Earth technologies and biological samples into alien environments? For example, landing robots on Mars or deploying probes into the oceans of Europa may carry risks of contamination and irreversible changes to the local environment. This risk necessitates the creation of strict protocols to prevent contamination and preserve the integrity of ecosystems that might be discovered. Ethical dilemmas also involve how we will use the knowledge and technologies we acquire. If we find resources such as water, minerals, or other valuable substances, how will we utilize them? Will we prioritize commercial gain, or will we make decisions based on principles of sustainable development and the protection of space ecosystems? These questions call for the establishment of international standards and agreements to regulate space activities and prevent the exploitation and destruction of alien worlds. Another critical topic is the colonization of other planets and its potential consequences. As plans for colonizing Mars and other celestial bodies become more realistic, we must consider the ethical aspects of this process. How will we allocate resources on new worlds? How will the rights and responsibilities of colonists be regulated? How will we address potential conflicts if they arise? These questions require careful consideration and the development of new ethical norms and legal frameworks. Space colonization also necessitates reflection on how we can avoid the mistakes made during past colonization efforts on Earth. The history of terrestrial colonization is filled with examples of exploitation, ecosystem destruction, and the oppression of indigenous cultures. We must learn from these mistakes and strive to create colonies based on principles of justice, sustainability, and respect for the new worlds we explore. It is also essential to consider that space colonization could create new forms of inequality and social injustice. If access to space and its resources is limited to only a few countries or corporations, it could exacerbate international conflicts and widen the gap between the rich and the poor. Therefore, mechanisms for governance and resource distribution must be developed that consider the interests of all humanity, not just select groups. Colonization also raises the question of territorial rights. If humanity begins to settle on other planets, how will we determine the right to land and resources? Who will decide which areas are suitable for colonization? And how will these territories be allocated? These questions require the creation of new legal norms that account for the interests of individual colonists and the international community as a whole. As we explore space, we bear responsibility not only to ourselves, but also to future generations. Our actions today may have long-term effects on the future of humanity. How will we use space resources? Will we act for the benefit of all humanity, or will our actions lead to new forms of inequality and conflict? These questions demand deep reflection and decision-making that considers the interests of future generations. The ethics of the space age requires long-term and global thinking. We must make decisions with an understanding of how they will affect the future of humanity and the entire planet. For example, if we begin to exploit the resources of asteroids or other planets, How will this impact Earth's ecosystems and future colonies? Will we deplete space resources as we have depleted Earth's, or can we create new models of sustainable development that ensure a future for all? This responsibility includes not only preserving resources and ecosystems, but also creating social and cultural conditions that will enable future generations to thrive. We must consider what values and norms we will pass on to our descendants, what technologies and knowledge will be available to them, and how they will use these resources to create a better world. Additionally, we must recognize that our actions in space may have unforeseen consequences. For instance, if we begin to alter the climate on other planets or use space resources to alter Earth's climate, how will this affect ecological balance and the sustainability of planetary systems? These questions require us to exercise caution and be prepared for long-term planning and risk management. The ethics of the space age also requires us to acknowledge our responsibility to future generations, not only as inhabitants of Earth, but also as inhabitants of space. We must recognize that our future is intertwined with space, and that our actions today determine what that future will be like for our descendants. This demands decision-making based on principles of justice, responsibility, and respect for life in all its forms. In conclusion, the ethics of the space age is not just a set of rules and norms. It is a deep understanding of our role and responsibility as inhabitants of not only Earth, but also the universe. Our actions in space should be aimed at creating a future that is just, sustainable, and safe for all living beings, and that considers the interests of future generations. Space offers us immense opportunities, but it also requires wisdom, humility, and a readiness to take responsibility. Space has always been a source of inspiration for humanity. It evokes a sense of wonder and awe, compelling us to reflect on our place in the universe and what we can achieve. In this context, space becomes not only an object of scientific study, but also a symbol of our highest aspirations. It combines both the scientific and spiritual aspects of our existence, inspiring us to create works of art, literature, and music, as well as engage in deep philosophical contemplation. Space has inspired countless writers, poets, and artists to create works that reflect its grandeur and mystery. Since ancient times, people have looked to the stars, finding in their steady glow a source of philosophical reflection and artistic imagery. In poetry, stars often symbolize eternity, steadfastness, and a connection to the divine. Cosmic themes have permeated literature, from ancient myths and legends to modern science fiction. Poetry about stars and space allows us to express our deepest emotions and thoughts about life, the universe, and time. Through poetic lines, space becomes a metaphor for human existence, a symbol of the eternal quest and the pursuit of the unknowable. Many poets, such as Walt Whitman, Fyodor Tyutchev, and Anna Akhmatova, drew inspiration from the stars and the night sky, creating works that remain relevant to this day. Space also inspires the creation of new forms of art. Virtual realities, digital installations, and multimedia projects allow us to travel through the universe, opening new perspectives and expanding our understanding of space and time. Artists use modern technology to visualize distant galaxies, black holes, and other cosmic phenomena, creating stunning images that immerse the viewer in the vast world of space. Moreover, space serves as a source of inspiration for musical compositions. Composers create symphonies, sonatas, and electronic tracks inspired by cosmic themes, attempting to convey the grandeur and mystery of the universe through sound. Music dedicated to space enables us to feel an emotional connection to the vastness, expressing our admiration and awe for the infinite. Science fiction plays a crucial role in shaping our perception of space and its possibilities. This genre of literature and film allows us to look beyond our everyday experiences and imagine what might await us in the distant future. Science fiction is not just entertainment. It shapes public opinion about science, technology, and the future of humanity, posing questions that have yet to be answered in reality and stimulating scientific inquiry. In works like Arthur C. Clarke's A Space Odyssey, Frank Herbert's Dune, and Gene Roddenberry's Star Trek, space is depicted as a realm of great discovery, but also as a stage for moral and ethical dilemmas. These works encourage us to think about what it means to be human, how we might interact with other civilizations if they exist, and what the consequences of our technological advancements might be. A Space Odyssey, for example, explores themes of evolution, artificial intelligence, and interaction with extraterrestrial intelligence. This work prompts us to reflect on our cosmic destiny and how we should use our knowledge and technology. Frank Herbert's Dune, on the other hand, immerses us in a world where planetary resources play a key role in politics and power, making us think about the consequences of space colonization and our responsibility to future generations. These works help us contemplate the future, what awaits us as we continue to explore space, and the challenges and opportunities this will bring. Science fiction not only inspires the creation of new technologies, but also warns of the potential dangers associated with their misuse. It plays a vital role in cultivating public awareness, fostering a sense of responsibility for the future of humanity and our planet. Space also holds deep spiritual significance. For many people, the stars and galaxies symbolize eternity, infinity, and the mystery of the universe. They inspire contemplation on the meaning of life, our connection to something greater, and our place in the cosmic order. The vastness and grandeur of space compel us to reflect on our insignificance on a cosmic scale, and at the same time, our uniqueness as beings capable of understanding and exploring this world. Space helps us realize how small and fragile our world is, and this realization can lead to new forms of spirituality based on respect for life and the pursuit of harmony with the surrounding world. For many, space becomes a source of inspiration for meditation, prayer, and philosophical reflection. It symbolizes not only physical infinity, but also the spiritual quest for higher meanings and ideals. The spiritual contemplation of space also gives rise to new religious and philosophical teachings that seek answers to questions about the nature of the universe, its origins, and the meaning of human existence. These teachings may merge science and spirituality, offering a new perspective on the world and our place in it. For example, ideas of pantheism, where the universe is seen as an expression of the divine, can combine with scientific discoveries, creating a synergistic understanding of space as a living and interconnected whole. Space also inspires the creation of new rituals and practices related to the reverence of natural forces and cosmic order. These rituals may include stargazing, celebrating astronomical events like solar and lunar eclipses, or meditating on infinity and eternity. Such practices help people feel connected to space and find their place in the grand chain of being. Furthermore, cosmic inspiration can lead to the emergence of new forms of ethics based on respect for nature and the universe. The ethics of the space age may include principles such as respect for life in all its forms, the protection of natural resources, and the pursuit of harmony with the surrounding world. These principles could form the foundation of a new worldview that considers not only the interests of humanity, but also the well-being of the entire planet and the cosmos as a whole. In conclusion, space as a source of inspiration plays a key role in the development of humanity. It helps us expand the horizons of our thinking, create new forms of art and spirituality, and shape our perception of the world and our place in it. Space is not just a domain we explore, it is an infinite source of inspiration that continues to fuel our creativity, dreams, and aspirations to the stars. When we look at the stars, we see not only distant worlds, but also our future. Space calls us to the stars, urging us to explore and discover new horizons. However, our cosmic legacy will be defined not only by what we discover, but also by how we treat these discoveries, our planet, and each other. The space age we are entering opens up infinite possibilities, but it also imposes a responsibility on us that cannot be ignored. The question of what legacy we will leave behind is not just a matter of future scientific discoveries, it is also a question of our moral and ethical choices. Our ability to explore and understand space comes with a great responsibility. We must understand that every step we take in space has consequences, not only for us, but also for the entire universe. We are not just explorers, but also custodians of space, and our legacy will be defined by how we approach this vast expanse. Space is not merely a lifeless void, but a complex, unexplored system where every action can trigger a chain reaction. We must be aware that our activities can affect other worlds, ecosystems, and potential life forms. Therefore, as we explore space, we must act with respect and caution, striving to preserve its purity and integrity for future generations. This requires the establishment of strict ethical standards and international agreements that will regulate space activities and ensure its preservation. Responsibility to the universe also includes our approach to using its resources. We must consider the long-term consequences of our actions, aiming for sustainable development and minimizing environmental impact. Space is a shared resource, and our legacy will depend on whether we can use it for the benefit of all humanity, not just for individual countries or corporations. This responsibility also extends to protecting and preserving natural processes that may exist on other planets and moons. Space gives us a unique opportunity to reconsider our place in the universe and understand that, despite all our differences, we are all part of one whole. The cosmic perspective helps us see that the boundaries and conflicts on Earth pale in comparison to the grandeur and scale of the universe. This realization can serve as the foundation for a new level of unity, where humanity is united not only for the sake of scientific research, but also for the common good. Cosmic unity requires us to rethink our priorities. We must place at the forefront not only scientific and technological achievements, but also social and cultural development that will promote peace, justice, and prosperity to all. In this new unity, we must learn to work together, overcome differences, and strive for harmony, both on Earth and in space. This idea of cosmic unity should also be the driving force in addressing global issues such as climate change, inequality, and poverty that threaten our shared future. Moreover, cosmic unity can become the basis for developing new forms of international cooperation and governance that will take into account the interests of all countries and peoples. We must strive to create a space community where resources and knowledge are distributed fairly, and decisions are made based on consensus and respect for the rights of all participants. This requires us to develop new governance mechanisms that will consider the interests of both developed and developing countries and ensure their equal participation in space activities. Our cosmic legacy is not just the result of our scientific and technological achievements, but also an expression of our values, culture, and quest for knowledge. How we conduct ourselves in space, the legacy we leave for future generations, will determine not only their future, but also our own history. This legacy will be a symbol of our pursuit of knowledge, understanding, and harmony. We must remember that our legacy is not limited to material achievements. It also includes the spiritual, cultural, and ethical aspects of our existence. We must strive to ensure that our cosmic legacy reflects the best qualities of humanity, our commitment to peace, justice, respect for life, and responsibility to future generations. This requires not only the development of science and technology, but also the cultivation of deep respect for life and nature within ourselves and future generations. Our cosmic legacy will also include the knowledge and technologies we pass on to future generations. We must ensure that this knowledge and these technologies are used for good, not harm. This requires the development of new forms of education and upbringing that will address the needs and challenges of the space age. We must prepare the next generation not only as scientists and engineers, but also as citizens of space, capable of making responsible decisions and acting for the benefit of all humanity. Space is not just a reality we explore, it is also a source of inspiration that continues to fuel our dreams and aspirations. It reminds us of the grandeur and infinity of the universe, that our quest for knowledge and discovery is part of our human heritage. Space inspires us to achieve great things, to create art, music, and literature that reflect our deepest thoughts and feelings. Our cosmic legacy will also be measured by how well we can preserve and pass on this inspiration to future generations. We must strive to ensure that space remains a source of inspiration for everyone, continuing to inspire people to dream and achieve great things. This requires the development of a culture based on respect for knowledge, creativity, and spirituality, which will contribute to creating a world where space becomes a symbol of our highest aspirations. Space teaches us to dream and strive for the impossible. It reminds us that the only limits are those we impose on ourselves, and that we can overcome them if we act with determination, courage, and faith in our abilities. Our cosmic legacy will be defined by how we use this inspiration to create a better world, to solve global problems, and to leave our descendants a planet and a universe they will look upon with pride and respect. As we conclude our journey, it is important to remember that the cosmic perspective is not just about looking at the stars. It is a new way of seeing and understanding the world, one that can change us and our society, inspire us to achieve great things, and help us become better stewards of our planetary home and wise explorers of space. Space is not just a domain we explore, it is also our legacy that we pass on to future generations. Our cosmic legacy is not just scientific discoveries and technological achievements. It is an expression of our pursuit of knowledge, our desire to understand the world and our place in it. It includes our responsibility to the planet and the universe, our pursuit of harmony, and our spiritual quest. This legacy, which we can leave to future generations, will be an expression of our desire for knowledge, understanding, and harmony. May our legacy be bright, inspiring, and worthy of those who will come after us, those who will continue our journey to the stars. Space not only expands our scientific understanding, but also evokes a sense of awe that finds expression in art. Throughout human history, stars and planets have inspired poets, artists, composers, and philosophers to create works reflecting their desire to understand the universe and their place within it. Science and art, seemingly opposite realms of human endeavor, converge in space, creating a harmony that reveals the depth and beauty of our existence. The idea of the music of the spheres dates back to the ancient Greek philosopher Pythagoras, who believed that the movements of planets and stars create a harmony that, while inaudible, is perceived on a soul level. This metaphorical concept suggests that the universe is full of music reflecting the order and beauty of the cosmos. Although Pythagoras envisioned an abstract idea, modern science has indeed discovered the sounds of space, radio emissions, gravitational waves, and vibrations in stellar atmospheres, which can be interpreted as music. Today, scientists and composers are using these sounds to create musical compositions based on real data. For example, recordings of gravitational waves detected from black hole mergers have been transformed into audio files that have inspired new musical works. These sounds, though not audible to the human ear in their original form, allow us to feel the pulse of the cosmos and touch its grandeur. Composers like Gustav Holst have created works influenced by space. His symphonic suite, The Planets, is a musical portrayal of the characters and mythological images of each of the known planets in the solar system at that time. Each movement of the suite conveys a unique mood and character associated with the planets, creating a musical portrait of the cosmos. Modern composers continue to explore space through music, creating pieces inspired by interstellar travel, black holes, and the majesty of galaxies. Electronic music, with its ability to create sounds reminiscent of the voices of space, has become particularly popular in this context. For instance, composer Vangelis created the soundtrack for the film Blade Runner, which conveys the atmosphere of a futuristic world inspired by space. Music inspired by space helps people delve deeper into the mysteries of the universe, uniting science and art in a common pursuit of knowledge. It allows us to experience cosmic space through sound, evoking emotions and reflections that cannot be expressed in words. Since ancient times, people have depicted stars and celestial phenomena in their works of art. Primitive cave paintings, ancient Egyptian star maps, and medieval astronomical manuscripts show how humanity has always sought to understand and depict space. These images not only reflect our quest for knowledge, but also serve as a bridge between spiritual and scientific perceptions of the world. Modern artists use the achievements of science and technology to create more accurate and captivating depictions of space. The works of artists like Chesley Bonestell played a key role in popularizing space in the 20th century, portraying future space missions and extraterrestrial landscapes with stunning realism. His paintings inspired a generation of scientists and engineers, motivating them to develop space programs and explore other planets. Visual art also helps us contemplate our place in the universe. Artists working in the field of space art create works that not only depict space, but also convey the emotions it evokes. Abstract paintings, photorealistic images of distant galaxies, and conceptual installations show how art can express our awe at the infinity and complexity of the cosmos. Space art also opens new forms of interaction and perception. With the development of digital technology and virtual reality, artists can create interactive installations that allow the viewer to immerse in space, explore it in three-dimensional spaces, and feel its scale and beauty. These installations become a bridge between science and art, helping us better understand the universe and our place within it. Literature has always played an important role in shaping our perception of space. In works of science fiction such as The Star Diaries by Stanislaw Lem or his Solaris, writers explore the philosophical and moral aspects of space travel and encounters with extraterrestrial civilizations. These works not only entertain, but also make us think about the profound questions related to our existence and our relationship with the universe. Science fiction allows us to look beyond the horizons of the known and imagine worlds and situations that remain beyond our understanding. It explores themes such as the future of humanity, the ethics of space exploration, possible forms of life on other planets, and many others. These works serve as a bridge between science and art, combining the rational and emotional perception of the universe. Moreover, literature about space contributes to shaping public opinion and inspires the development of science and technology. Many scientists and engineers admit that it was science fiction that sparked their interest in space and science. Literature about space helps us better understand our cosmic destiny and inspires the pursuit of knowledge and discovery. Literary works inspire not only scientists and engineers, but also the general public. They help us imagine what life might be like on other planets, what difficulties and challenges await us in space, and what moral dilemmas may arise in the future. They also help us realize that space is not just a physical space, but a place where various ideas, philosophies, and ethical concepts collide. Photography has played a key role in popularizing space. The first images of the moon taken through telescopes sparked a wave of interest in astronomy, and photos of Earth taken from space changed our perception of our place in the world. Images like the famous pale blue dot have become symbols of unity and the fragility of our planet, prompting reflections on its protection and our place in the cosmic scale. Space cinematography, from classic films like Stanley Kubrick's 2001: A Space Odyssey to modern blockbusters like Christopher Nolan's Interstellar, plays an important role in shaping our understanding of space. These films not only entertain, but also inspire viewers to think about humanity's future, its pursuit of knowledge, and the moral and ethical questions that may arise in the process of space exploration. Cinematography allows us to see space through the eyes of directors and screenwriters, creating visual and emotional images that stay with us for a long time and encourage us to make new discoveries. Space films help us imagine future space missions, possible encounters with extraterrestrial civilizations, and even the fate of humanity in the context of large-scale cosmic events. Additionally, cinematography and photography play an important role in education and popularizing science. Documentaries about space, such as Cosmos: A Space-Time Odyssey, with Neil deGrasse Tyson, make science accessible to a wide audience, explaining complex concepts in an engaging and understandable way. These films and photographs inspire a new generation of scientists and engineers who will continue to explore space and discover new horizons. Space, with its grandeur and mystery, unites science and art, creating a harmony that inspires us to seek knowledge and creativity. Scientific discoveries and artistic works inspired by space enrich our culture and help us better understand the universe and our place in it. The interaction between science and art in the context of space shows that these two fields are not opposites, but complement each other, creating a complete picture of reality. Science gives us an understanding of the physical laws of the universe, while art allows us to experience it emotionally and spiritually. Together, they create a cosmic symphony, a harmony that reflects our quest for knowledge, beauty, and understanding. Space continues to inspire people to great discoveries and creations. May this harmony of science and art continue to fuel our desire to reach for the stars and help us find our place in the vast expanse of the universe. Space has always been a source of inspiration and ambition for humanity. But in this pursuit, we must also consider the future that awaits us and our descendants. What decisions must we make today to ensure a future where humanity continues to thrive and evolve? How do we prepare for the challenges that the space age will bring? These questions require deep reflection and preparation, as our future in space will be determined not only by our technical prowess, but also by our ability to cooperate, make responsible decisions, and respect nature. Modern technologies, such as artificial intelligence, nanotechnology, biotechnology, and robotics, have a profound impact on our ability to explore space. These technologies not only accelerate the process of space exploration, but also open new horizons that once seemed unattainable. However, alongside these opportunities come new challenges that require a responsible approach. Artificial intelligence, for example, could become a key tool in managing space missions, analyzing data, and making real-time decisions. However, with the development of AI, questions arise about how we will control these systems and what ethical principles will be embedded in their operation. How will we interact with intelligent machines if they reach a level comparable to human intelligence? Will these machines serve humanity, or could they become autonomous entities requiring special status and rights? Nanotechnology and biotechnology also open new possibilities for space exploration and colonization. They can be used to create materials and medicines that will work effectively in the extreme conditions of space. However, these technologies also raise concerns about their potential impact on human health and the environment. How will we regulate the use of these technologies to minimize risks and ensure their safe application? The development and use of new technologies demand a responsible approach. We must consider not only our current needs, but also the long-term consequences of our actions. Technologies can become powerful tools for solving global problems such as climate change, energy security, and environmental protection. However, this requires developing and implementing technologies with ethical and environmental standards in mind, as well as respecting the rights of all people and future generations. A future where technologies are used for the benefit of all humanity requires a new level of global cooperation and understanding. International standards, agreements, and joint projects should become the foundation for the development of technologies that will promote peace and sustainable development. This also necessitates the creation of mechanisms for monitoring and controlling the use of technologies to prevent their misuse or harmful application. Education plays a crucial role in preparing future generations for life in the space age. We must not only teach children science and technology, but also instill in them a sense of responsibility and global thinking. Space education should become the foundation for forming a new worldview in which a person understands their role as a steward of Earth and an explorer of the universe. Space education should include not only technical knowledge, but also the study of ethical and philosophical issues related to space. Students need to understand that space is not just a new resource to be exploited, but an environment that requires respectful and careful handling. It is important to develop critical thinking in children and adolescents, the ability to analyze complex problems and to find solutions that consider the interests of all humanity. Moreover, space education should encourage creativity and the pursuit of new discoveries. We should inspire children to dream of the stars, to ask questions, and to seek answers, even if they seem unattainable. This requires creating educational programs that inspire and motivate, while providing the necessary resources to develop scientific and technical skills. Space education should also include elements of an interdisciplinary approach, combining science, art, philosophy, and social sciences. This approach will help students understand how different fields of knowledge interact with each other and how they can be used to solve complex tasks related to space exploration. It is also important to focus on ethics and human rights to raise a new generation that will act responsibly and with respect for life and the environment. The future of space exploration requires a new level of international cooperation. We must unite the efforts of all countries and peoples to jointly explore space and address global challenges. Space is the common heritage of all humanity, and we must strive to study and develop it in a spirit of peace and cooperation. International space projects, such as the International Space Station, ISS, are examples of how nations can work together for the common good. The ISS brought together the efforts of various nations, demonstrating that even in the face of political differences, successful collaboration in space is possible. This experience shows that joint work in space can become a platform for improving international relations and strengthening global peace. However, the future of space cooperation must go beyond current projects. We need to create new international initiatives aimed at exploring deep space, studying other planets, and searching for extraterrestrial life. This requires developing new mechanisms for funding, data, and technology sharing, and creating joint scientific and engineering teams that will work for the benefit of all humanity. Global cooperation in space exploration also requires overcoming barriers related to inequality in access to space resources and technologies. We must ensure that all countries, regardless of their economic development, have the opportunity to participate in space projects and benefit from their results. This calls for mechanisms to transfer technologies, train specialists, and support scientific research in developing countries. Furthermore, global cooperation in space should be based on the principles of transparency and trust. We should aim for open information exchange, joint mission planning, and coordinated decisions that consider the interests of all participants. Only through cooperation and mutual respect can we achieve sustainable and peaceful space development. As space activity expands, the need for new international norms and laws governing the use of outer space arises. How will we address issues of ownership of asteroid and other celestial body resources? How will we prevent conflicts in space? These questions require the development of a new legal framework that considers the interests of all countries and ensures the fair and sustainable use of space resources. Creating a legal framework for space activities requires broad international dialogue and cooperation. Current international treaties, such as the 1967 Outer Space Treaty, provide a foundation for regulating activities in space, but they need updating and expansion to meet modern realities. We must develop new agreements that address issues of resource ownership, liability for space activities, and conflict prevention in space. One of the key issues is the regulation of resource extraction on asteroids and other celestial bodies. Who will own these resources? How will revenues from their extraction be distributed? How will we ensure that the use of these resources does not lead to environmental and social problems? These questions require the creation of international management and regulatory mechanisms that consider the interests of all countries and ensure the fair distribution of resources. Moreover, measures must be developed to prevent conflicts in space. How will we resolve disputes over the boundaries of outer space and the rights to its use? How will we prevent the militarization of space? These questions require the creation of an international legal system based on the principles of peace, security, and cooperation. Space is a shared environment, and we must care for its preservation for future generations. We must develop legal and regulatory mechanisms that ensure its sustainable use and prevent pollution and destruction of outer space. This requires the creation of new standards and norms that consider the environmental and social aspects of space activities. Space and the future of humanity are inextricably linked. Our quest for the stars opens new opportunities, but it also demands a responsible approach and global cooperation. The future where humanity continues to thrive and evolve depends on the decisions we make today. Our task is to use technologies for the benefit of all humanity, to develop education that prepares new generations for life in the space age, and to create a legal framework that ensures the fair and sustainable use of outer space. Space is not only our future, but also our responsibility. May our quest for the stars be guided by the principles of peace, cooperation, and respect for life in all its forms. Space reflects our dreams, fears, ambitions, and aspirations. It shows us how small and vulnerable we are, but also how great our potential can be. In this vast expanse, we find ourselves and reconsider our place in the universe. Space, like a giant mirror, returns our own gaze, revealing both our greatest achievements and our deepest doubts and anxieties. It becomes a tool for self-discovery and a catalyst for personal and collective growth. The cosmic perspective helps us better understand ourselves. When we look at the stars, we see not only distant worlds, but also the reflection of our own aspirations and potential. Gazing into the infinite reaches of space reminds us that we are but tiny particles in a vast universe, yet endowed with a unique ability to comprehend our existence, ponder the meaning of life, and explore the world around us. The realization that we are part of a vast cosmic order can inspire us to create a more just and peaceful world, where science and art serve the advancement of humanity and the protection of our planet. The cosmic perspective teaches us humility, reminding us that our daily concerns and conflicts are insignificant compared to the infinity of space. This awareness can become a driving force for global cooperation and the search for solutions that will promote sustainable development and the well-being of all humanity. Space also helps us see how interconnected we all are with each other and our planet. In this context, Earth is perceived not merely as a place of residence, but as a unified organism, requiring care and attention. The cosmic perspective can inspire the development of ethical and ecological consciousness, based on respect for life in all its forms and the pursuit of harmony with nature. Awareness of our smallness on a cosmic scale should not frighten or deprive us of meaning. Rather, it should encourage self-improvement. Space reminds us that despite our insignificance, we have the ability to change the world, to advance science, art, and technology, and to strive for a better future for all. This awareness should inspire us to bold actions, to the pursuit of truth, and to the quest for justice. Furthermore, the cosmic perspective allows us to rethink many of our established beliefs and values. Looking at Earth from space, we begin to understand that national borders, social differences, and political disagreements lose their significance in the face of cosmic reality. Space helps us realize our shared destiny and our responsibility to future generations. The quest for the stars is not only a scientific and technical achievement, but also an expression of the human spirit. Space has always been a symbol of our highest aspirations and dreams. We seek knowledge, new discoveries, and to expand the horizons of our understanding. This quest reflects not only our thirst for knowledge, but also our deep inner need to go beyond the known, to overcome limitations and to reach a new level of awareness. Space is a challenge that forces us to overcome our fears and doubts in order to reach new levels of understanding and awareness. In this pursuit, we find meaning and purpose, which gives significance to our existence. Space travel, like all great endeavors of humanity, requires courage, determination, and a willingness to take risks. They become a metaphor for our inner journey, our struggle with our own limitations, and our striving for self-improvement. The history of space exploration is full of examples of the human spirit manifesting in the most challenging and dangerous conditions. Space pioneers like Yuri Gagarin, Neil Armstrong, and many others not only achieved technical and scientific success, but also demonstrated the strength of the human spirit, willing to take risks for the sake of discovering something new. Their feats inspire millions of people around the world, reminding us that we are capable of great achievements if we act with determination and courage. The quest for space also prompts philosophical reflections on the nature of life, consciousness, and the universe. What does it mean to be human in the vastness of space? What new forms of life might we encounter? How will our perception of reality change if we discover that we are not alone in the universe? These questions stimulate our quest for knowledge and compel us to seek answers that may change our understanding of the world and ourselves. Moreover, the quest for the stars unites science, art, philosophy, and spirituality in a single drive towards knowledge and self-development. Space becomes the stage for realizing our most ambitious projects and our deepest reflections. It unites the rational and the intuitive, the technical and the aesthetic, creating a new synthesized form of thinking that can lead us to a new understanding of the world and our place in it. Space, as a mirror of humanity, reflects our achievements and failures, our dreams and fears, our ambitions and aspirations. It compels us to strive for better, to seek a deeper understanding of ourselves and the world around us. In this pursuit, we find meaning and purpose, which give significance to our existence, inspire us to great achievements, and guide us on the path to self-improvement and harmony with the universe. Space, as a mirror, not only reflects us, but also transforms our perception, urging us towards new discoveries and self-awareness. It becomes a conduit for a deeper understanding of our place in the universe and the role we play in this grand cosmic drama. May our quest for the stars always be accompanied by the awareness of our responsibility, our connection to the world, and our aspiration for self-improvement and harmony with the surrounding reality. When we think about space, we inevitably return to reflections about ourselves, about who we are and who we can become. Space is not just vast expanses, but a mirror reflecting our deepest aspirations and fears. In space, we see not only the potential for new discoveries, but also a challenge that demands responsibility, wisdom, and courage. In this conclusion, we will attempt to summarize the key thoughts and principles that should guide us in the space age. We live in a unique time when humanity is beginning to actively explore space. This places a tremendous responsibility on us. Space, like Earth, is a common heritage that we must preserve and pass on to future generations. We cannot afford to repeat the mistakes of the past, where reckless use of resources led to the destruction of ecosystems and the suffering of millions of people. The space age requires us to reach a new level of awareness of our responsibility, not only to our planet, but also to the entire universe. We must strive for peace and cooperation, for the protection and preservation of space resources, and for the development of science and culture for the benefit of all humanity. This responsibility includes not only the use of space resources, but also the protection of worlds we may discover. If we ever find life beyond Earth, we must regard it as an equal participant in the cosmic community, worthy of respect and protection. Moreover, we must recognize our responsibility to future generations. Our actions in space today may have long-term impacts on the future of humanity. We must think not only of short-term benefits, but also of long-term consequences. This requires us to develop ethical principles and legal norms that will guide our behavior in space, ensuring its sustainable use and protection. Cosmic responsibility also entails the need to preserve and protect humanity's cultural heritage. This applies not only to the preservation of our achievements on Earth, but also to respecting what we may discover in space. We must strive to ensure that our presence in space enriches and develops our culture rather than destroys it. The future is both an opportunity and a challenge. Space opens new horizons for us, but also presents new questions and tasks. How will we use these opportunities? How will we respond to challenges? These questions encompass our ability to adapt, learn, and make responsible decisions. The future of space offers us enormous opportunities for scientific discoveries, technological innovations, and social progress. We can create new forms of energy, find resources that will help solve global problems on Earth, and even find answers to the most fundamental questions about the origin and fate of the universe. However, to realize these opportunities, we must be prepared to overcome significant challenges. One of the main challenges we face is maintaining peace and cooperation in space. Space should not become a battleground for conflicts and competition. Instead, we must use it as an opportunity to unite the efforts of all countries and peoples to solve common problems and achieve common goals. This requires the development of international agreements and legal norms that will regulate the use of space and prevent its militarization. Another important challenge is the ethical issues related to the use of new technologies. How will we use artificial intelligence, biotechnology, and other advanced technologies in space? How will we protect the rights and freedoms of people working and living in space? These questions require deep reflection and the development of new ethical principles that will take into account the interests of all participants in space activities. Moreover, the space future challenges us to preserve our planet. While space provides us with new resources and opportunities, we cannot forget the need to protect and preserve Earth. Space should become not a replacement for our planet, but its continuation, an extension of our understanding and care for life in all its forms. The answers to these questions will determine our future and our cosmic legacy. But regardless of what that future holds, one thing remains constant: the pursuit of the stars, of knowledge, and of self-improvement that makes us human. This pursuit should be the guiding force in our space endeavors, driving us to explore, discover, and create anew. Space, with its infinite possibilities and challenges, is a mirror of our ambitions and fears, our wisdom and responsibility. Let our quest for the stars always be accompanied by the awareness of our responsibility to the universe, our planet, and future generations. And let our cosmic legacy be a symbol of peace, cooperation, and the pursuit of knowledge that unites us all in this great cosmic journey. Humanity has always sought to understand its nature and its place in the universe. This quest has led to the greatest scientific discoveries, inspired the creation of remarkable works of art, and prompted deep philosophical reflections. Space, with its vast expanses and unexplored mysteries, is not only an object of study, but also a mirror reflecting our dreams, fears, and hopes. Our journey into space is not merely a physical voyage to the stars, but also a spiritual journey towards self-discovery and understanding our place in this grand cosmic order. When we look at Earth from the heights of space, we see a fragile and unique world that is our home. This tiny pale blue dot in the vastness of the universe reminds us that we are one humanity bound by common destinies and shared challenges. Space teaches us humility and the necessity of caring for our world and each other. We must remember that despite our differences, we all share one planet and one destiny. Realizing our unity should become the foundation for a new worldview where cooperation, peace, and respect for life are paramount. The cosmic perspective helps us understand that our future depends on our ability to work together, overcome differences, and strive for common goals. In this unity, we find strength and inspiration to overcome any difficulties and create a better world for all. Space calls us to new discoveries, to expanding the boundaries of our knowledge and understanding. This call cannot be ignored, as it reflects our deep human nature, the desire to explore the unknown, ask questions, and seek answers. But in this pursuit, it is important to remember our responsibility to future generations. We must explore space not for conquest, but for knowledge, not for exploitation, but for cooperation and peace. Space exploration is an opportunity for all of humanity to unite in the quest for knowledge and the achievement of new horizons. It opens up possibilities that once seemed unattainable and provides a unique opportunity to learn from each other, share experiences, and build the future together. Space is a stage for global cooperation, where science, culture, and philosophy can unite in a common pursuit of knowledge and wisdom. What legacy will we leave behind? This question should be central to our reflections on the future. Our cosmic legacy will be defined not only by what we discover, but also by how we act towards space and each other. We stand on the threshold of a new era, and our actions will determine whether this future will be one of peace and cooperation or of new conflicts and destruction. The legacy we leave must reflect our highest ideals, striving for justice, peace, and environmental protection. It should become a symbol of our wisdom and responsibility, our quest for knowledge and understanding. The space age demands from us not only technical and scientific achievements, but also moral maturity that will help us make the right decisions and pass on our legacy to future generations. Space is not just a place we can travel to. It is also a source of inspiration, knowledge, and wisdom. It encourages us to reflect on the meaning of life, our purpose, and the future we want to create. Our journey to the stars is not only a scientific and technical achievement, but also a path to deep self-discovery and an understanding of our connection to something greater and eternal. In this infinite universe, where every atom of our body was once part of a star, we find our place and our purpose. We are travelers, explorers, and keepers of knowledge, and our journey is just beginning. On this journey, space will be our companion and teacher, inspiring us to great deeds and reminding us that our future is in our hands. Space opens up endless horizons of possibilities, but it also demands maturity and responsibility from us. Let our quest for the stars be not just a race for new discoveries, but a thoughtful journey where every step is aimed at creating a better world for all. In this journey, space will be not only a realm for exploration, but also a mirror in which we will see the reflection of our true selves, our values, and aspirations. Thus, our cosmic journey is not just a physical movement forward, but also a spiritual development, a path to harmony with ourselves, with each other, and with the universe. May this path lead us to the stars and beyond, opening new worlds and new opportunities for self-discovery and the flourishing of all humanity. Sagan, the universe is an immense and enigmatic cosmos that has captivated humanity for millennia with its boundlessness and grandeur. The ancient peoples, gazing up at the starry skies with reverence and wonder, laid the foundation for an endless quest to understand what lies beyond our world. We observed the movement of celestial bodies, sought to comprehend their cycles and patterns, built astronomical observatories, and created myths to explain the origin of the universe and our place within it. Each generation contributed to this ceaseless pursuit, passing down accumulated knowledge and a profound sense of awe at the majesty of the cosmos to future generations. Over time, our tools for understanding the universe became more sophisticated. Technological advancements have allowed humanity to peer into the farthest reaches of the cosmos, to witness the light from distant galaxies, and to observe the birth of star systems. We have learned to use telescopes, satellites, and space probes to explore space, revealing many mysteries hidden within the vast expanses. Yet, as we discover more, new questions arise, questions that are even more complex and profound. What is the universe? How did it come into existence? What role does humanity play in it? These questions remain relevant today, despite all the achievements of science and technology. Modern cosmology is a science that not only unveils the mysteries of the universe's origin and evolution, but also helps us understand the nature of time and space, the forces that govern galaxies, stars, and planets. At the core of these studies lie the fundamental laws of physics, which explain how the initial singularity known as the Big Bang gave birth to the universe approximately 13.8 billion years ago. This moment, filled with energy and matter, marked the beginning of everything we know, the beginning of time, space, and all that fills the cosmos. From chaos emerged structure, stars, and galaxies, within which planets eventually formed, one of which became our home. Despite our insignificance on the cosmic scale, humanity has always strived to understand its place in this vast expanse. We are but specks in the infinity, yet within our minds and hearts burns a desire for knowledge. How did life arise on Earth? Are we alone in the universe? What future awaits humanity? These questions present not only scientific but also philosophical challenges, prompting us to contemplate the meaning of existence and humanity's role in the cosmic scale. Throughout history, we have sought answers to these questions, yet each answer we find leads to new mysteries. We see stars that extinguished millions of years ago, observe galaxies that we will never approach, and realize that our lives are but a fleeting moment in the infinite chain of events occurring in the universe. In this text, we will embark on a fascinating journey through the vastness of space, from the origins of the universe to its possible end. We will explore how our understanding of the cosmos has evolved, what discoveries scientists have made, and what questions remain unanswered. We will also seek to understand humanity's place in this infinite universe and how our understanding of space can influence our future. In this journey, we will consider not only scientific aspects, but also the philosophical and cultural implication of our discoveries, striving to comprehend what it means to be human in such a vast and mysterious world. Space is not just the void between stars, it is an ocean of time and matter, where every atom of our bodies was born in the hearts of distant stars. Understanding this connection to the cosmos opens up new horizons, driving us to further exploration, new discoveries, and perhaps a re-evaluation of our place in this grand cosmic order. We embark on this journey not only to seek answers, but also to experience the beauty and grandeur of the universe. to realize our connection to it, and to find inspiration in its boundlessness. The universe we inhabit is a grand and awe-inspiring object of study. It is home to billions of galaxies, each containing billions of stars and an incalculable number of planets, comets, and asteroids. Everything we see and everything that exists is governed by the same physical laws that describe the behavior of matter and energy. But how did this vast and complex structure come into being? The question of the universe's origin remains one of the most profound and intriguing mysteries of modern science. According to the prevailing theory, our universe emerged from a state of extremely high density and temperature around 13.8 billion years ago in an event we refer to as the Big Bang. The Big Bang is not merely an explosion in the conventional sense. Rather, it represents the moment when space and time, as we know them, began to exist. At this moment, all matter and energy were concentrated in a single point, known as a singularity. This state was so extreme that the physical laws we use to describe everyday reality could not be applied. Gravity, electromagnetic forces, strong and weak interactions, all these fundamental forces existed in a form that we have yet to fully comprehend. It was a moment of pure potentiality, a moment when everything that exists today was in a nascent state, waiting to be born. From this singularity, the universe began to expand, and this expansion continues to this day. This process can be imagined as the incredibly rapid inflation of space, where every point moves away from every other point, similar to how points on the surface of an inflating balloon move away from each other. It is crucial to note that this expansion is not happening within pre-existing space. Rather, space itself is expanding. This distinction highlights the uniqueness of the Big Bang as an event that initiated not only matter and energy, but also the very concepts of space and time. Initially, immediately after the Big Bang, the universe was incredibly hot and dense. Temperatures reached trillions of degrees, and matter existed in a form with no modern analog. In these conditions, elementary particles such as quarks and gluons were in a state of free movement, forming a kind of soup. These particles interacted with each other, constantly being created and annihilated until the temperature gradually dropped to the point where quarks could combine to form protons and neutrons, the building blocks of atomic nuclei. Something remarkable was occurring. From the primordial chaos and disorder, ordered, structured matter began to emerge. Within the first few minutes after the Big Bang, processes of nucleosynthesis began, leading to the formation of the first nuclei of light elements, such as hydrogen and helium. These processes occurred under conditions where the density and temperature were so high that individual nuclei could collide and fuse, forming heavier elements. This initial nucleosynthesis concluded relatively quickly, leaving behind a universe primarily filled with hydrogen and helium, along with trace amounts of lithium and other light elements. These light elements became the foundation for the subsequent formation of stars, galaxies, and all the structures we observe today. It is important to note that this process was not random. It followed specific physical laws that operated with incredible precision and predictability, creating the conditions necessary for the formation of complex structures from the primordial material. Thus, the Big Bang not only marked the beginning of everything that exists, but also laid the groundwork for the development of the universe as we know it. One of the key pieces of evidence for the Big Bang theory is the existence of the cosmic microwave background radiation, CMBR. This radiation, a sort of echo of the Big Bang, represents the relic light left over after the universe cooled and became transparent to photons. In the first moments after the Big Bang, the universe was opaque to radiation due to its high density and temperature. Photons, particles of light, constantly collided with electrons and other particles unable to travel freely. However, about 380,000 years after the Big Bang, the temperature dropped to the point where protons and electrons could combine to form neutral hydrogen atoms. This process, known as recombination, made the universe transparent to light. From this moment on, photons were able to move freely, and this radiation, which we observe today as the CMBR, became a sort of photographic imprint of the early universe. The CMBR reveals that the universe was nearly homogeneous in its early stages, with very slight density fluctuations. These fluctuations are believed to have been caused by quantum processes occurring during the moment of inflation and eventually became the seeds for the formation of galaxies and star systems that we observe today. These small density variations became the regions where gravity began to concentrate matter, leading to the formation of the first stars and galaxies. The discovery of the CMBR in 1965 by Arnaud Penzias and Robert Wilson was a crucial confirmation of the Big Bang model and provided scientists with a deeper understanding of the early stages of the universe's development. Detailed study of the CMBR using modern satellites such as COBE, WMAP, and Planck has allowed us to create an accurate map of the early universe, measuring its age, composition, and density. These data confirm that the universe is indeed expanding, and that its history began with the hot, dense state we call the Big Bang. While the Big Bang theory gives us a general picture of the universe's origin, it does not explain all the details. For example, it cannot account for why the universe appears homogeneous and isotropic, that is the same in every direction, on large scales. Questions related to the flatness, homogeneity, and lack of magnetic monopoles in the universe remained unresolved within the framework of the classical Big Bang theory. To address these issues, the inflationary theory was proposed, which suggests that in the first fractions of a second after the Big Bang, the universe underwent a period of exponential expansion known as inflation. Inflation was a brief but extremely powerful period of expansion during which the size of the universe increased by trillions of times in a minuscule amount of time. This process smoothed out any initial irregularities and made the universe nearly uniform in all directions. Without inflation, different regions of the universe, located far apart from each other, would not have been able to agree on their properties, as the speed of light limits the exchange of information between them. However, inflation explains how these regions could come to such an agreement despite their distance. Inflation resolved several problems of the standard Big Bang model. First, it explained the homogeneity and isotropy of the universe, as during inflation, any initial inhomogeneous distribution of matter and energy was smoothed out. Second, the inflationary theory provided an explanation for the origin of the density fluctuations that led to the formation of structures such as galaxies and galaxy clusters. These fluctuations arose from quantum fluctuations, which were stretched to macroscopic sizes during inflation. Additionally, the inflationary theory predicts the existence of primordial gravitational waves, ripples in space-time that could have been generated by this rapid expansion. The search for traces of these waves in the CMBR is one of the tasks of modern cosmology and could be key to confirming or refuting the inflationary model. Inflation also opens the door to deeper questions about the nature of the very beginning of time and space. What caused inflation? What conditions led to its initiation and termination? How are these processes related to quantum gravity and possible theories of everything? These questions remain subjects of active research, and their resolution could lead to a new understanding of not only the universe's origin, but also the fundamental laws of nature. Thus, the Big Bang and the subsequent inflation laid the foundation for the formation of our universe as we know it. This beginning, filled with both revealed mysteries and new questions, is only the first step on a long journey that scientists continue to explore, striving to understand both the universe itself and our place within it. After the period of inflation ended, the universe continued to expand, but at a much slower pace. This stage can be seen as the beginning of a long process during which the universe began to take on its modern characteristics. Space was still filled with hot and dense gas, composed of elementary particles, which were just beginning to form into more complex structures. It was during this phase that processes began, leading to the emergence of atoms, stars, galaxies, and other cosmic objects that we observe today. Approximately 380,000 years after the Big Bang, the temperature of the universe decreased to the point where protons and electrons could combine to form neutral hydrogen atoms. This process, known as recombination, marked a significant milestone in the history of the universe. Before this moment, free electrons hindered the propagation of light, and the universe was opaque. However, after recombination, photons could travel freely, leading to the emergence of the cosmic microwave background radiation, CMBR, which we observe today. Recombination also led to the formation of the first helium atoms and traces of lithium. These light elements formed the foundation for the subsequent formation of stars and galaxies. It is important to note that at this stage, the universe was primarily a dark place, not in the sense of the absence of light, but in the sense of the absence of visible structures. It is believed that this was the beginning of the so-called Dark Age of the universe, when light had not yet been emitted by the first stars, and space was filled only with rarefied gas and dark matter. Even during this time, important processes were occurring. Dark matter, which does not interact with ordinary matter electromagnetically, but exerts gravitational influence, began to concentrate in dense regions, forming a sort of skeleton for future galaxies. This process of gravitational contraction of matter into dense regions became the foundation for the formation of the first stars and galaxies. Several 100 million years passed after the Big Bang before the first stars began to form. These stars, known as population 3 stars, became the first sources of light in the young universe. They consisted almost entirely of hydrogen and helium, since heavier elements did not yet exist. These stars were much more massive and brighter than modern stars, with masses exceeding hundreds of solar masses, and their lives were short and turbulent. Population 3 stars played a key role in the processes of nucleosynthesis, enriching the interstellar space with heavier elements such as carbon, oxygen, and iron. These elements, known as metals in astrophysics, became the basis for the subsequent formation of planets and more complex chemical compounds necessary for the emergence of life. These early stars also contributed to the ionization of hydrogen in the surrounding space, a process known as the epoch of reionization. Reionization was the process in which the ultraviolet radiation from the first stars and galaxies ionized neutral hydrogen, splitting it into protons and electrons. This process ended the Dark Age and ushered in a new era where visible structures, stars, galaxies, and galaxy clusters began to form. Reionization was an important stage in the evolution of the universe, as it laid the foundation for the formation of the first galaxies and large-scale structures we observe today. As population 3 stars evolved and ended their lives in powerful supernova explosions, they enriched the surrounding space with heavy elements, creating the conditions for the formation of subsequent generations of stars, population 2 and population 1 stars, which make up most of the stars observed today. These subsequent generations of stars became the building blocks for the formation of galaxies, such as our galaxy, the Milky Way. As the universe continued to expand, gravity played a key role in the formation of large-scale structures. Gravitational forces led to the contraction of matter into dense regions, where galaxies, galaxy clusters, and superclusters began to form. In these regions, new stars formed, and the interstellar space filled with gas and dust, creating the conditions for the birth of planetary systems. The formation of galaxies and large-scale structures in the cosmos is a complex and multi-stage process involving gravitational interactions, collisions, and mergers of galaxies and the dynamics of dark matter. Dark matter, which makes up most of the mass in the universe, created gravitational wells into which ordinary matter was drawn, forming galaxies and their clusters. Modern astronomy observes various types of galaxies: spiral, elliptical, and irregular. These forms reflect the complex processes of mergers, interactions, and the evolution of galaxies. Spiral galaxies, like our Milky Way, have beautiful spiral arms where stars actively form, from clouds of gas and dust. Elliptical galaxies, on the other hand, are older and more tranquil systems where star formation has nearly ceased. Irregular galaxies have chaotic shapes and are often the result of gravitational interactions or mergers with other galaxies. Galaxy mergers are an important process that significantly impacts their evolution. When two galaxies collide, their stars and gas clouds begin to interact, which can lead to bursts of star formation, the formation of new star clusters, and even changes in the galaxy's shape. In some cases, a merger can lead to the formation of an elliptical galaxy from two spirals. For example, our galaxy, the Milky Way, likely formed from the merger of several smaller galaxies and continues to evolve through the accretion of matter and star systems. In the future, our galaxy will collide with the neighboring Andromeda galaxy, and this collision will lead to the formation of a new, larger galaxy that may become elliptical or lenticular. The development of galaxies and large-scale structures is one of the key processes in the evolution of the universe, and it continues to be studied by astronomers worldwide. Observations made using powerful telescopes like Hubble and James Webb help scientists not only peer into the distant past of the universe, but also understand how it will evolve in the future. These studies give us insight into how the universe gradually evolved from the hot and dense state characteristic of the Big Bang to the grand and complex structure we observe today. The evolution of the universe is a process that continues, and we are part of it. Understanding this process helps us better comprehend our place in this vast and ever-changing cosmic order. The question of whether life is unique to Earth or widespread throughout the universe is one of the most exciting in modern science. Life as we know it requires certain conditions to exist, such as the presence of liquid water, specific temperature ranges, and a particular chemical composition. However, on the scale of the universe, these conditions might be found in the most unexpected places. There are billions of stars, each potentially hosting its planetary system, and while conditions on most of these planets are likely unsuitable for life, even a small percentage of habitable worlds opens vast possibilities for the existence of extraterrestrial life. Earth is the only known place where life exists. The emergence of life on our planet remains one of the greatest mysteries of science. How did life arise from non-living matter? This question has occupied the minds of scientists for centuries. It is believed that life on Earth originated approximately 3.5 to 4 billion years ago, during a period known as the Hadean Era. At that time, Earth was a hot, volcanically active world with an atmosphere rich in carbon dioxide, methane, and ammonia. Despite these extreme conditions, chemical processes occurring in the oceans and atmosphere created the conditions for the emergence of the first organic molecules. The process of life's origin involves several key stages. The first step was chemical evolution, during which simple molecules such as water, methane, ammonia, and carbon dioxide began to form more complex organic compounds, amino acids, nucleotides, and lipids. These molecules could have formed through various natural processes, such as electrical discharges, ultraviolet radiation, or thermal energy, for example, in deep-sea hydrothermal vents. The next critical stage was the aggregation of these organic molecules into more complex structures, proto-organisms capable of self-replication and metabolism. This stage is the most mysterious, as the exact mechanisms that led to the emergence of the first self-replicating systems are still unknown. However, it is believed that RNA molecules, which are capable of both storing genetic information and catalyzing chemical reactions, may have played a crucial role in this process. Over time, these simplest organisms became increasingly complex, passing through stages of evolution that led to the emergence of prokaryotes, then eukaryotes, and eventually multicellular organisms. These changes occurred over billions of years, resulting in the vast diversity of life forms we see today, from microorganisms to complex organisms such as plants, animals, and humans. The origin of life on Earth is also closely tied to the evolution of the environment. For example, the emergence of photosynthesis, which produces oxygen, altered Earth's atmosphere, creating conditions for the development of aerobic organisms and ultimately more complex forms of life. This process also led to the formation of the ozone layer, which protected the planet's surface from harmful ultraviolet radiation. The question of life beyond Earth has been a subject of discussion and speculation for centuries. With the advancement of science, this question has become the focus of serious research. Today, scientists actively study various objects in the solar system and exoplanets located in habitable zones where conditions might be suitable for life. Mars, for instance, has long been considered one of the most likely candidates for harboring life. Recent missions, such as the Curiosity and Perseverance rovers, are exploring the planet's surface for signs of ancient life, such as organic molecules and geological structures indicating the presence of water in the past. Although the surface of Mars today is cold and dry, there is substantial evidence that liquid water may have existed on the planet in the past, a key condition for life. Geological data suggests the existence of rivers, lakes, and possibly entire oceans in ancient times, which could have created favorable conditions for microbial life. Moreover, the moons of the giant planets, such as Europa and Enceladus, also attract the attention of scientists. Beneath their icy crusts, there may be oceans of liquid water, potentially capable of supporting life. The water geysers observed on Enceladus, ejecting plumes into space, indicate the presence of a subsurface ocean that might be heated by hydrothermal vents on the ocean floor. These conditions could be analogous to those that existed on early Earth, representing potential niches for life. However, the search for life is not limited to the solar system. Thanks to advances in astronomy, scientists have discovered thousands of exoplanets, planets orbiting other stars. Some of these exoplanets are located in the so-called habitable zones, where conditions might be suitable for the presence of liquid water. An example of such a planet is Proxima Centauri b, which orbits the star Proxima Centauri, the closest star to us beyond the solar system. The search for life on these exoplanets involves not only observing their atmospheric characteristics, but also searching for biosignatures, chemical traces that could indicate the presence of life. Molecules such as oxygen, methane, and ozone might suggest biological activity if found in significant quantities in the atmospheres of these planets. Current and future telescopes, such as the James Webb Space Telescope, will play a crucial role in searching for these biosignatures and understanding the potential for life beyond Earth. One of the most intriguing questions regarding extraterrestrial life is the so-called Fermi paradox, named after the physicist Enrico Fermi. The question Fermi posed is simple: where is everybody? If life is widespread in the universe, why do we not see any signs of other civilizations? This question has led to numerous theories and speculations about the nature and fate of intelligent life in the universe. There are various answers to this question. One hypothesis suggests that intelligent life in the universe may be extremely rare. Perhaps the conditions necessary for the emergence of intelligent life are so specific that they only occur on a few planets. Moreover, even if intelligent life does emerge, it may not last long due to various threats such as global catastrophes, self-destruction, or technological barriers. Another hypothesis proposes that advanced civilizations might be avoiding contact with us or using technologies that we have not yet detected. This idea is known as the zoo hypothesis or cosmic quarantine, suggesting